what we can use to improve this situation. Many of you may know OWASP has a project called OWASP Mobile Security Project. One of the things they provide is top 10 mobile risks. This might be a good start for people who want to start running the mobile security. Educational tools such as Xcode, DBIA, it stands for Dumb Vulnerable iOS Applications, are also probably useful for people who want to run mobile security. As for secure development of iOS apps, OWASP Mobile Security Project provides OWASP top 10 mobile controls and iOS developer cheat sheet. These resources probably help iOS developers to develop the secure iOS apps. IMAS is a security libraries of iOS apps. This is also one of the OWASP projects. We've never used it, so we don't know the details. But maybe you can try to use it. Regarding security testing, we have iOS application security testing cheat sheet. But do you know anything else you can use for security testing? What kind of tools, what kind of things, documentations you use for security testing for iOS apps? Well, yeah, there are several free tools we can use for security testing. Dynamic analysis tools and penetration testing frameworks, such as iAuditor, Analyzer, Snippet, Introspy iOS. If you never used some of them, maybe you can try. As for commercial tools, there are several commercial static analysis tools and services to test iOS apps. However, we did not know any free security source code analysis tools for iOS apps when we started our project. At that time, we spent a lot of manual work for security testing and needed to heavily use grep scripts to identify issues. But it was necessary for our security tester to check results manually if it's the false positive or not. Also, we thought secure coding guideline itself did not work dramatically because it might be pretty annoying for developers to refer to the guidelines very often. Furthermore, we expected to provide developers a tool which can detect security issues at earlier phase of development. That's why we decided to we decided to develop Xcode plugin to extend security features in order to centralize developer-friendly security features on the IDE, because we believe that's pretty essential because developers always live in IDE. And we also expect to provide a solution to avoid making vulnerabilities and detect vulnerabilities at earlier phase of development. And we also expect cut down the cost of manual security testing for iOS apps. So here's a quick intro to Xcode plugin development. Have you ever developed a plugin for Xcode? Oh, nice. Two, nice. What kind of plugin you developed? Did you develop, sorry.
Did I develop a plugin for Xcode? No. I think I misunderstood you.
Sorry. Did you develop something? Some plugin?
I was playing around modifying one.
Modifying. Okay, great. So what you need to do to create the plugin is to choose bundle as a template and Cocoa as framework. And do some configurations and create your class and build, relaunch Xcode. That's it. This is pretty easy. So you can start developing your plugin if you're interested in. But unfortunately, Apple doesn't provide any official documentation for Xcode plugin development. That's a hard part. So if you want to utilize the internal frameworks from your program, you need to understand what each frameworks do. So there are some of the frameworks we analyze and we utilize from our program. ID Kit, ID Foundation, you can find these frameworks in this particular directory. And DBT Kit, DBT Foundation, and many others. So using a tool called ClassDump, you can extract the internal class information, such as class name, method name, properties, and so on. So this is the example of the interface declaration of ID source code editor. Maybe you can guess what this does, right? So you can see here there is a method called version. Maybe you can guess. If you use this method, you can get the version of ID source code editor. So you need to guess what each method properties do. So now there are many Xcode plugins developed and released by a bunch of folks. Xbin is a key binding of bin for Xcode, developed by one of his friends. Jagroshu. This is pretty good. And injection. If you use injection, you can modify the Objective-C code without restarting an application. This is also good. And there are many others. So our program is called Xsecurity. It has three main features. First one is quick security help with built-in security guidelines. The second one is real-time vulnerability notifications. And the last one is static analysis with current static analyzer. So first feature, quick security help. I'm going to explain quick help first. So quick help is the default feature of Xcode, which displays concise reference documentation without taking focus away from the file developers editing. So you can find information in quick help inspector area and quick help window. So the idea is to add the security guidelines in reference documentation to both quick help inspector and quick help window. And also, it can also automatically display and hide inspector area. So Raymond is going to explain the second feature and third feature.
Okay. For our second feature, we call it real-time vulnerability notification. As its name suggests, it shows the issues being created by the developers. In turn, it provides the developers an instant know-how on the issues they're trying to create. And lastly, it serves as a preventive measure in order to prevent those people from committing those issues earlier on the development phase. So assuming that the source code has issues, these notifications can be shown when the user is trying to modify the source code, and also when the user tries to switch between source files. So how did we do it? We kind of researched the parts of Xcode, as he mentioned. Actually, he did most of the things there. And we tried to realize how it works. And one of our internal things that we do is we categorize those vulnerabilities according to their qualities or characteristics. And lastly, we use a lot of regular expression to detect these issues. For our third feature, we call it Clang Static Security Analyzer. Basically, we made our custom-built Clang, and then we tried to use it to analyze the source code. And we try to integrate the custom-built Clang in our Xsecurity plugin. So what is Clang? Probably most of you know already. I'm just going to run through it. Clang is a compiler front-end for C family of languages, and using LLVM as its backend. It creates an abstract syntax tree of the source code. And LLVM community is backed by the big names in the industry like Apple, Google, ARM, Intel, and etc. It's also said that they said that Clang will replace the GCC. So there's their objective about Clang. So inside Clang, there's a static analyzer. It is able to find those bugs in C family of languages, including Objective-C. Clang can also be executed from command line and also within Xcode. And this is open source project under Clang project. So alternatively, there's an alternative tool that we're supposed to use, but we did not. It's called OCLint. It uses Clang plugin to check the source code, but it falls short in the capability of traversing the source code path execution. So that's what we thought, as far as we know. So we didn't use this tool instead. So the static analyzer performs a path-sensitive exploration of the program. It basically relies on the checkers to implement the logic for bug detection and creation of bug reports. There's also a documentation, as you can see, but if you want to try your own, build your own Clang, or create your own checker, this documentation is kind of not enough. So there's fewer how-tos, let's say, how to do some things, how to traverse the code and all. So you need to dig up the manual, and also you need to dig up the source code of Clang.
Is there anybody who developed the current checkers? No one? Okay.
So as mentioned earlier, Clang can be executed from command line. So inside the Clang project, there's a scan build script, which you can use with your favorite continuous integration system, like Jenkins. So you can execute it with your daily builds or whatever builds you have. So for the vulnerabilities that we're able to support, 10 of them, and 5 of which can be detected by real-time vulnerability notification. The categories, as you can see, there's like insecure data storage, insufficient transport layer security, and so on. Really fast. Anyway, yeah. We applied for it to become a OWASP project, so you can check it out in OWASP.org. Also, we tried to make the source code open, so you can check us out in GitHub. Just search Xsecurity. Also, you can follow us on Twitter if you want to know about the updates on our releases and all. Oh, yeah.
Yeah, go ahead.
I'm sorry. So we're kind of fall short of contributors, so if you are interested, feel free to join us.
Yeah, so we just have a alpha release version, so we are looking for more contributors to develop more checkers, more rules, to detect many more issues for iOS developers.
So in the future, we would like to make the configurations flexible and customizations on guideline in quick security help. One note on this feature, one developer of us mentioned that what if we can modify this to, if you have code conventions, right? Some people would like to have these code conventions. So they thought, like, what if you can make this more flexible so that you can implement your own code convention in your development team. So that's one idea from our developers. And we'd like to also to have a rule selection and improve reporting functionalities. And also more rules to add. And hopefully we can support Xcode 6.0 and later, and Swift possibly, if possible. And so these are the remaining vulnerabilities that we hope we can support in the future. So as of now, we don't know yet how we can make this fit into our plugin. So if you please don't ask us questions about it. And we're gonna show you some demo on how we do it, on how we show those functionalities.
Okay. Move it. Didn't work. What? Something wrong. What? Maybe we should exit the slideshow first and then go to here.
Yeah, just this thing.
Where is it?
No. We're having some difficulties, so.
Sorry, wait a minute. Finder. Yeah, here they go. Where's Castle?
Yeah, cursor's here. So you have to go there. Where's it?
Oh, yeah, here it is.
Yeah, cursor.
This one. It's very difficult. Can you see query? It's. Okay. Should we turn the right on?
Yeah.
Maybe we should.
No, I'm sorry, we actually can't dig the live because it's
Streaming?
Okay. So
Okay.
just zoom in or choose another I just
Yeah. We can't even see.
It's looking?
It's almost impossible to.
But if you change the background color, maybe it's a movie.
Background color, yeah, it's movie, so. Yeah.
Anyway, we're really sorry about this. We're just gonna proceed probably. We didn't put it in there.
Or maybe I can use my laptop to do actual demonstration.
Yeah.
Maybe. But I think you have, right? The Xcode, right?
I
You
do
don't-
have, but it's not the.
Yeah, please do something. Do you know how to change the Xcode prefix? Color scheme? I forgot. Editor. Maybe here. I don't know. Huh? Yeah, maybe this one. Okay, cool. Yeah, can we use that? Where is it? All right. This one. Okay, cool. This should be this one. Right? This one. Okay.
Is it better?
Okay, good. I can't show you the menu, but you can choose the menu Xsecurity. If you install a plugin, you can find the menu called Xsecurity, and there are 3 menu items. If you can choose Quick Security Help, you can activate that feature. So let's activate it. Then if you're a developer and you type like nslog, then it automatically showed the warning security guidance in the inspector area, which is something developers need to be careful. In this case, you shouldn't log the sensitive information by using nslog. That's what it says. When it focuses away, it automatically hides the inspector area. If the developer doesn't want to always show the inspector area, it might be helpful. The second one, let's disable this feature. Second one is vulnerability notification. You can also activate vulnerability notification from menu. I activated it. You comment it out? Maybe. Yeah. Can you explain?
No, yeah, just continue.
Yeah, this one. I just commented out, uncommented out?
Yeah.
The vulnerable code. So you can see yeah, so you can see here our custom annotations. So once you click the annotation, you can get more information. It goes here like this. So with the reference, if you click the reference, it takes you to the OWASP Mobile Top 10 webpage. A particular risk category of OWASP Mobile Top 10. Here's another example. It's insecure permanent credential storage. So here a developer tried to store the credential permanently, which is not good. So it reports it. So this is what real-time notification is. The next one, yeah, where is it? This one. Should I clean up? And maybe this one. Yeah, here you go.
So in our custom menu, you can find a third item, which is static security analyzer. You can select it. We cannot show it right now, but there's a third item, and then when you click analyze, you select analyze, it will execute our custom.
It failed. Sorry, maybe it's not. Maybe we should show the video for us. Yeah, okay. I'll try to fix it. Is this working? Try this one.
So for the static analyzer,
Yeah.
sorry about this, but so we mentioned earlier that there's a, as you can see, there's a
Can you maximize it?
yes, as mentioned earlier, we added this menu in the Xcode, and there's three items that we were trying to mention earlier: the quick security help, vulnerability notification, and the static security analyzer. So in this video, we're trying to show that selecting this analyzer will show the feature. So when the user selects it and then you, try to execute analyze, it will show you the issues. There are two. Please take note that there are 4 issues on this issue navigation area. We're going to discuss about side channel data leakage and client-side injection. So when you click it, it will show you which is the problem. In this case, this one is for this NSLog. So when you select the annotation, as you can see it in here, it will show you the path on how you come up with a problem like this, because it knows the path execution, so it will display these arrows. In this case, I'm just going to explain the problem. The problem here is the user uses NSString format instead of using parameterized SQL query. And then, so in this video, we're going to show you also how we fixed it. So in the case of NSLog, you just need to just comment it out. So probably you can see the comment out there above, again above. And then for this, in this case, the query string has been removed and it's been replaced by a parameterized query in here. And then after that, the user needs to bind that, the parameter by calling bind text, SQLite bind text. And after, so when we try to execute again the analyze, it will show you that on the navigation area, the issue navigation area, the 2 vulnerabilities has been removed and fixed. You can see it in there.
You should move to the right.
So this is pretty much it. So do you have any questions, comments, while interaction?
In the beginning, you said that HP research identified 9 out of 10 iOS applications are riddled with common vulnerabilities, and the vulnerability categories were listed. I think about 4 categories in the HP research. Can you compare how the worst problems are addressed by your analyzer, and did you find that you needed to solve first the ones that were easiest to solve, or did you try to solve first the vulnerabilities that are most common?
So the question is referring back to the slide that we showed, the HP's research, right? Or IOActive, or somewhere those.
Or you are asking about the IOActive's research? Maybe we should go to
It was on the second or third page.
Yeah,
I think
so.
it's
Yeah, let's
working.
go back.
Actually, while you were talking, I looked up the original research from the link at the bottom. This one. Next page with 3 links at the bottom.
This one?
Next,
One before.
yeah, this one.
This one.
There's 3 links here. I thought it was interesting. 90% of apps show security vulnerabilities. I saw here the ZDNet link, and I went to it on my phone
Okay.
while you were talking, and I read the vulnerability
cool.
categories, and they tended to be
Uh,
privacy violation and insecure transport.
I see. But the way of categorizing
Yes.
the vulnerabilities are probably different from what we do.
Okay.
So, and I don't remember how they categorize.
Okay.
So that, I think, I found it several months ago. But, so your question is?
My question is, did you try to solve the most common problems first?
Yes, we do.
Okay.
Some common problems. We try to find, we can find the 10 issues now, but we need to find many more issues. But most of them are common issues, common mistakes developers make. So, but there are many more, so we need to make more effort to create other checkers rules. Okay, thank you.
Thank you. Hi. Yes.
Hi. Yeah, fairly simple question. So is the objective of this project in relation to commercial products such as Fortify and Veracode, is the intention to provide an alternative to those, or does it kind of complement them?
So the question is, we mentioned about commercial products. So the question is it kind of complements them?
Yeah,
Yes,
so
right.
so is the intent for developers who perhaps can't afford or don't want to invest in those on those commercial products, or is it more a case to augment what you would get with those as well? So does this provide coverage that perhaps those products wouldn't cover?
We are not sure, such commercial products work. Such commercial products fine. So we don't want to pay a lot of money for that. So we just wanted to develop, free tool to help developers to find issues. But I believe, such commercial tools find similar issues that what we can find.
Yeah.
But I think for now, commercial tools may be able to find more issues. Thank you.
Thank you.
Hi, thanks for the presentation. So my question is, if the other tools, other static analyzers, like the one that you saw before, I don't remember the name, instead of the Clang static analyzer, can you take, or maybe one of these vendors like Fortify or Veracode, can you take those results and put them together in the results, like you're showing with Clang static analyzers, with this, this way of presenting the results in a unified way, in a unified console in the IDE? Can you take external results from other tools, maybe from other static analyzers, and put them with, show them together with a Clang static analyzer? Or is that possible at all?
Yeah, the question is, can we pull out some data from other vendors and then compare it, something like that, right?
Mm-hmm. Yeah, maybe even from dynamic tools that have different approaches. Can you take other results and put them, show them in the Xcode, in the way that you present the Clang static analyzer results?
I think it is possible in a way that you can use Clang static analyzer in command line interface. So those results can be queried, and then if other vendors or whatever their results can also be extracted, so we can make it a format, something like that. That's just an idea, but I'm not really sure if that's really possible. So because we have this in development that when you do it, you have to do it first before you kind of decide that's going to be really possible. Just an idea, maybe that's possible.
Mm-hmm. Okay, thank you.
Welcome.
The hooks that you use to get into Xcode, did you guys, is that a documented API, or is it something that you reversed from your own by researching it?
Yeah, we analyzed the internal frameworks by ourselves. There's
So
no
it's-
official documentation.
Right, so it's going to be unstable. So and the next version of Xcode could cause,
Yes, we actually had some problems when we got the Xcode 5.0.
and what about with the Clang, the AST in Clang, is it also similarly, it seemed like that was documented.
Yes, the Clang part is kind of documented. They have the Doxygen documentation on how can you do that.
Automated.
So that part's documented, but the hooks back into the IDE are you're using undocumented APIs.
Yes,
Yes.
Thanks.
Thank you.
thank you. So I think this concludes our presentation. Thank you very much for your time.
Thank you very much.
So, good morning, everyone. Welcome to my talk entitled Intent on Being a Good Android Citizen. It's not that easy to read with the OS template, but its subtext is defensive strategies and techniques for developers. So before I start, I just want to spend a few moments talking about what a defensive strategy is. And a defensive strategy is a way of writing your code so that it's always secure. And the opposite of that is it's sometimes possible to write code that is secure in some circumstance and insecure in another circumstance. An offensive approach aims to be secure always. And this is quite important for developers because they often don't understand the various contexts that their code could be used in. So just a little bit about me. I'm Andrew with a funny spelling. I'm a security consultant. What you need to know about me is that I used to be a software engineer. I used to be a developer. And I've been working with Android for at least the last 2 years now at this company called Xsecurity, doing predominantly Android assessments. I do other stuff, but it's mostly been about Android for the last 2 years. So when I talk to you today, I'm talking to you a little bit as a developer and as a tester. So what about you? Can I just have there's not that many of you, can I have a show of hands? Are any of you developers? So one developer, 2, 3, 4, excellent. And not a developer, show of hands? Okay, so nobody's perfect, but so I'm speaking primarily to developers, but I'm also speaking to testers. So if you're a developer, you really want to be able to write secure code without thinking about all the edge cases. And that's really where I'm speaking to today. So best practices, gotchas. If you're not a developer, I'm hoping there's still something in this talk for you. Perhaps you need to write remediation guidance for assessments that you've done, and remediation guidance is not actually always that easy to write. I'm not going to talk about attacks, but some of this may still be useful to you. And even if you can't lift the remediation guidance, the approach behind the remediation guidance might chime. So my agenda is to do a quick primer, and then I'm going to talk about 6 rules. 6 rules for intenting safely. And when I looked around on the internet, you have 7 ways to hang yourself with Google Android, 3 ways to ace your first interview, 5 ways to be secure. I couldn't find anything 6 rules for something. It just happened to land up that way. So the rules are be explicit about exported, and that's just about not leaving things to chance. And that's really simple. It's something you can do in your sleep, but if you don't do it, it can have severe consequences. The next one, point 2, is same old, don't trust the input. Number 3 is a special case for assuring intent origin when you're handling system events, or when you're handling events that you think are from the system, but they may not be from the system. Common mistake. Point 4 is about being explicit when you're talking within your app, in intra-app communication. Point 5 is speaking to data sensitivity, and point 6 is validating some assumptions that if you don't validate the assumptions, the whole security of your app could be undermined. Right. This is not actually that easy to use. It's a bit flaky. So what is an intent? Just a quick primer. Intent is a way to make a way to do inter-process communication, something along the lines of a remote procedure call between a sender and a recipient. And there's the option of having a return path. And when we, as developers, tend to think of intent in a sort of a holistic way, under the hood, there's a few different concepts. There's the addressing, the naming of the recipient. There's the data that's exchanged, and actually the interprocess mechanism that's used, the RPC call. But when we tend to think of these, and for the purpose of this talk, you tend to think of a single abstraction. So here's an example, a specific example. I have a sender who wants to start an activity, which is a piece of user interface the user can interact with, creates an intent, says, I want you to do this action, and here's the data I want you to use, dispatches the intent, and presumably the activity reacts to that and performs the business logic. Really simple. So, to speaking to the three things I mentioned earlier, intent can be something called implicit or explicit. And that's explicit really means you name the target. So there's an example. I want this intent to go to the greeting activity and greeting package, set it up and dispatch the intent. An implicit intent is one where the sender creates the intent and lets the system choose who the recipient is. So here's an example. I want someone to perform the view action. Here's the data. Here's some additional information. And the system chooses the recipient. Now, in order for all of this to work, the receivers, the recipients, need to somehow advertise the kinds of intents they can handle. And that's done very flaky. How do I scroll back? This is there. That's done. Is there another way to control this? Because this is very, yeah, I think I will. So I'm going to use the keyboard. So that's done using something called an intent filter, where the recipients advertise what kind of intents they're interested in. The system goes through some sort of resolution process. But intent filters are not security boundaries. Everyone knows that. But it's a common source of mistakes that lead to security vulnerabilities. And finally, intents, and this is really important, intents can be, in the top example, between apps, inter-apps, or they can be intra-app within an app. Now, as the diagram there shows, that's a developer abstraction. There's nothing about the intent API that actually sends the intent within an app. Or there is an edge case, you can actually do it. In process, you get a strong guarantee. But in general, that's just an abstraction that the developer sees. And as a result, if they don't do it correctly, if they make mistakes, then an attacker can be in the game. The final part of the primer is just going over something called permissions. Most people know what permissions are. If you're an Android developer, this will be old hat. But permissions are like labels in an access control system that protect IPC participants. They protect other types of data, but for the purpose of this talk, I'm only interested in intents. And the important thing is that intents they are predefined, and developers can define their own intents. And in the beginning, every app has no permissions. It starts off having no permissions, and they request permissions, and there are three ways, for the purpose of this talk, 3 ways that they are granted. Like, if the permission is classified as normal, system grants it automatically. If the permission is classified as having protection level dangerous, then the user has to approve the installation of an application. And finally, there's a signature or system, which I'll treat the same. And that is that a permission is granted to an app if it is signed with the same certificate as the permission in which it was declared. So app 1 signed with the developer's certificate, app 2 signed with the same certificate, app 2 declares requests permission in app 1 and is granted that permission automatically. So here's some quick examples. Permission protects recipients. There's an example of a receiver, and it says, if you want to talk to me, you need to have this permission. So what does that mean? It means that a sender that has bind device admin can talk to this receiver, because you must have bind device admin. In this case, it provides assurance that only the system can talk to my example receiver. Whereas a component that does not have the permission can't talk to my example receiver. So permissions protect receivers. But permissions protect broadcast senders. And the important bit of code is the one at the bottom. A component creates an intent, says, you can have this, you can receive this if you have this permission, must have this permission, and then just dispatches the intent. So here's the same example diagrammatically. The recipient says, to receive this intent, you must have this permission. Some receiver is able to receive the intent if it has been granted the permission, but if you do not must have this permission, you don't get the intent. So that's really straightforward. So let's look at my 6 rules for intenting safely. Be explicit about exported. Treat all input intent data as evil. Verify the intent origin. Use only explicit intents. Avoid sending sensitive data. And validate your assumptions. So let's look at the first one. So this is so easy, there's no reason not to do it. You can just do it in your sleep. So there's an attribute that controls whether a component is public or private. It's called exported. And if it's true, it's public, meaning other apps not having the same user ID can send intents to your app. And if it's false, that means only root or apps having the same user ID can send intents to your app. So there's an example. If it's true, app 1 can send to app 2. If it's false, app 1 cannot talk to app 2. If they have the same user ID, then they can still talk to each other. And the question is, what if you don't use this flag? What if you don't use it? Now, most developers will be aware of what happens, but the actual answer is it depends. Now, it depends is not a good answer from a security perspective. You want certainty. It may be exported, it may not. If it has an intent filter, it's exported. But if it's a provider and you don't have exported and the min SDK version is 16 or less and the target SDK version is 16 or less, then it actually is exported, otherwise it's not. That's an example. So we don't want uncertainty. And that's why you need to be explicit. The default value is inconsistent. And the second reason really is it conveys design intent. It's the idiomatic way of saying this should be for intra-app intents only. And if you don't do this, you open up yourself up to attack. Rule number 2 is same old, same old. Again, this is so easy, you can do it in your sleep. For all intent handling code, internal and external, do some basic actions. Put a preamble in your intent handler. So the first thing I do is basic stuff. I check the action is not null. If it's not null, I check it's the action I expect, and I do that for everything else I depend on. I mean, it's input validation 101. Validate the action, validate the extras, do everything else you need to do. Check that. So let me give you an example of what happens if you don't do this. And this is, I've assessed 2 apps that make these basic mistakes. So here I have a screen lock app. It's got something really critical running. It must be running at all times, and I've got an attacker. So what can my attacker do? Well, let's say my screen lock app just does this. It just gets the action. It says if the action is the action I expect. What can the attacker do? Well, the attacker can create an empty intent. Simplest of attacks. Creates an intent, doesn't put anything in it, names the screen lock app as the target and sends the intent. Now, how do we know it's an empty intent? Right? It's a hollow block there. Should be a good hint. And what's going to happen should be fairly obvious. Null point exception, app crash, screen lock bypass. Trivial mistake. Just because I didn't check for null. Here's another example. Here I forget to check the action. I need to put a bit of background around this example. So here I have a receiver. It advertises that it's interested in something called a package added action, an event. This particular event is guaranteed to be broadcast by the system. It's a protected broadcast, and my receiver is taking some action when the system sends this broadcast event. And here's the code. This is what it does. This time it checks the action, forgets to check the value. Checks null for null, forgets to check the value. And then it uses some data that's being put in the intent, some extras. So what can an attacker do? Now, an attacker can't send package added, because that's protected. System, in this case, protected broadcast system will check that. But the attacker can send intent foobar. Create an intent with action foobar. He can address my receiver, and he can send the data. And he can spoof the intent, because I didn't do something as simple as checking the action. And I can get that app to do something it shouldn't be doing. So that's a really easy rule to remember. Just do input validation. Very easy to do. So rule number 3, special case. For system broadcast intents, verify the origin. Now, this really speaks to broadcast intents that you think that the system does send, but you may be mistaken in thinking that's only the system that can send them. So you can fix this in 2 ways. You can infer that it must be the system by saying, well, I'm going to put a permission around my receiver and say, only the system, this is a permission only the system can have. Therefore, if I get this intent, it must have been the system. Or you can do it programmatically. And I'm going to show you the easy way, because generally declarative security trumps dynamic checks. But this is the first way. So before that, I'll just explain why. Well, I think I've explained it already. So many broadcasts are assumed to be protected broadcasts, so they're vulnerable to intent spoofing. So here's an example. It's a common thing for two-factor apps to have SMS as an additional channel. So here's part of my app, GWizBang multi-factor auth receiver. It's interested in SMS received messages, and presumably inspects the message and maybe presents a pin on the screen for the user to type into their favorite banking website. They type it in, they get access. So the system does indeed send SMS received messages. But so can an attacker. An attacker can't do that implicitly, but they can do it explicitly. So they can just create a new intent, SMS receive, name the target, boom, send it to my app. And they can spoof that second factor. So the way to fix that is, well, the first example, indirectly, is to say, well, if you want to send this to me, you must have the broadcast SMS permission, which I know is a signature permission that is owned by the system. Therefore, I've verified the origin. Only the system can send it. So, rule number 4, use explicit intents for internal communications. So internal communications really is just a recap. When you have components within an app, intra-app components talking to each other, and as I said, showed in the primer, that's really a developer perspective. So just to remind ourselves what an explicit intent is, it's creating an intent and naming the target. Now, I've got 2 stars there because I didn't want to do this because there's always an exception. So, and in this case, there are actually 2 exceptions. I need to be specific, unfortunately. So, for internal communications, you always want to use explicit intents. But Android does provide a stronger guarantee via something called Local Broadcast Manager, which allows you to send intents in process. So you don't even have to worry about security. And here's an example. I register a receiver, and later on, within the app, I send a broadcast intent to the receiver, and I don't have to worry about security because it's in process. I don't have to worry about permissions. It's the best kind of security. That's the exception. But for everything else, you want to use explicit intents if you can't use local broadcast receivers. So why? This is nothing new. 2011 there was a very good talk, 7 ways to hang yourself, Google Android, and it's called unauthorized intent recipient. I'll just take you through it very quickly. So there's my example. I create an implicit intent. I put some data in it. I put an action in, and I dispatch it. And if you recall, the system chooses the recipient. So I have my legitimate app and I have my bad app. And my bad app wants to get that intent for nefarious reasons. So what can he do? Well, if you remember, apps advertise the kinds of intents they receive. So bad app can define an intent filter, and he can load it, he can stuff it to be the preferred recipient. And if all else fails, he can even set a priority to grab the intent. Now, the way the system handles these things is slightly different for activities or broadcast receivers or services. But usually that's not an obstacle. So this is my second edge case, if you don't know the addressee. Now, I wonder if any of you have ever had a situation where you find a SQL injection and you say to the developer, use parameterized queries. So they, yeah. So they go off. And they bring it back and you test it and it's still vulnerable to SQL injection. You say, show me the code. And they've used a parameterized query, but they've done the string concatenation right on top of it. This is this case for Android. So I've said use explicit intents. So here's an example. Down at the bottom, and I really see this, they create an explicit intent by setting the target. So this is explicit. But before they do it the equivalent of the string concatenation, and they query the system, and they say, system, who's interested in this intent? Grab the name, then grab the target, whether it's an activity or a service. They get the name, and then they create an explicit intent from it. Well, what they've really done is create an implicit intent. And a lot of code, some apps, when they try and write plug-in functionality, they do this kind of thing. They want plugins, and so they go through this dance. So this is the edge case. So if you do that, just put a permission check around it. Say, well, yes, okay, you must have this permission before I send this explicit intent. Now, the Android API has a send broadcast with a permission. But start activity, the activity RPC and the service functions to start a service stoppers, those do not have permissions in their signature. I think that's a pretty strong design hint that you shouldn't be doing this at all. But if you do it in a secure way. How am I doing for time? Okay. Yeah, okay, good. 2 more. So the next one is avoid sending sensitive data in intents. Now, there are a lot of good reasons for doing that. So here's an example. I create an intent, I stuff it with sensitive data, and then I send it. Now, you should avoid not doing this. Or if you're an assessor, you should look at this and suggest as remediation guidance, don't do this. It's well known, you have the sticky broadcast, the leak information, you create a sticky broadcast, it's totally unprotected, it gets rebroadcast to new receivers, don't do that. You can hijack services, and services tend to be in a trusted, once you start a service, it tends to be trusted, you may exchange information with the service, there are other ways you can do it. So I'm going to show you another way. So probably many people are familiar with this on Linux, where I start a program, and if I pass sensitive information on the command line, it leaks. If it just query the proc file system, look at the command line, I can see all the sensitive information. So that's many people are familiar with that problem. So you can do the same thing on Android. It depends. I mean, it depends, but that can happen. That can happen. You can get the base intent for activities in new tasks if you have the get task permission, and if there was any sensitive information in there, then you can just pull it out from the base intent. So it's the analogy for the top part of the slide. Now, they've done some stuff, they've tweaked some stuff. You now need a different kind of permission. I'm not sure if a user would actually understand that permission, but they've fixed it. So this is a little bit more nuanced because you need to change the design somewhat. Actually changing the design has some advantages. But the basics is that you pass a reference to the data and you have the recipient fetch the data. You don't pass the data itself. And that puts the onus on the recipient to have the permission to then go and fetch the data. So it simplifies the design in some ways. It's something of a trade-off. So last rule is validate your permission assumptions on startup. What does that mean? So the question is, you have a permission. Is that permission actually your permission? So this is a well-known problem. The first permission registration wins. But it's only sort of recently people started to talk about it a little bit more. It's been known for quite a while. It's the standard behavior. So here's an example. Bad app is installed first and declares good app's permission and downgrades the protection level to normal. And then requests that permission. It doesn't need it, it's normal, so it's just granted automatically. And then good app comes along later and says, well, yeah, I want to protect myself with good app.permission. And I'm going to make this protection level signature, so no one except my developer can grant this permission. So there's Android permission. And then I protect myself with that permission. I say, oh, my receiver, only you must have this permission to talk to it. So the entire sort of fabric of my app depends on whether that permission is really what I think it is. So why is that important? Well, I've made an assumption. I'm protecting my app with my permission. And that's the basis of my assumption. And if that assumption is wrong, I actually have no protection whatsoever. So the fix is do a dance, go through your permissions, declare it compare it to all the other permissions in the system, and have a look at them. Now, someone has done that for you. It's on GitHub. You could put this code in your startup for your app. There is a bug in that code. When I reviewed it the other day, the author is aware of it, so hopefully he'll put a fix. It's an edge case, so hopefully it won't affect. Sorry, I'm running quite fast then. So there is a bug, but he says he's going to fix it. So I'm running a little fast. Okay, so summary. Be explicit about exported, rule number 1. Treat all input as evil, rule number 2. For system intents, make sure you're sure that it's from the system. Use explicit intents. If you're going to talk internal communications, use explicit intents. Avoid sending sensitive data in intents. And finally, validate your assumptions that you make about the security of your app when it comes to permissions. So that's all. I'm running quite early, but thank you for listening. And if there are any questions, do so now.
Would you recommend separating signatures for So would you recommend separating signatures based on the how security intensive the apps are?
Would I recommend separating signatures? Could you give me an example?
I have banking apps and I have some marketing apps, and would you recommend having different signatures for those?
For different apps. So the apps are signed with different signatures. You're not talking about permissions. You're just talking about signing apps with different signatures. So I'm not too sure I fully understand the question, but I'm going to answer it in a different way, and hopefully I answer it in this. I'm actually not a big fan of permissions, of creating loads of permissions in the first place. I think a lot of things that are done with permissions can be done with an additional step, additional screen where the user approves things, and you can actually eliminate the requirement for permissions. In fact, it's Google's advice, don't go creating loads of permissions because it just complicates things. So back to your question about different apps, I mean, that depends on the context. Are those apps, is there some trust relationship between the apps that they need to be signed by the same certificate? And if there is, then, and they need to, they are logically part of the same app, they share the same user ID, or they need to use signature permissions, then you have to sign them with the same certificate.
But otherwise, should that be something of a concern? So
the rule of thumb is minimize trust between apps. So that's your starting point. Apps don't trust each other at all. And there should be no signature permissions. They're not signed by they're not running on a shared user ID. That's the starting point. And then slowly relax those constraints as you find the requirements really dictate that you need to do that. But a design guideline, start with no trust, and then really challenge those trust assumptions as you develop the app.
Thanks, Andrew. It was really good talk, actually. So just a question on the last issue described about the way the platform handles custom permission.
Yes.
Don't you think it's something that maybe the platform should do in a better way?
There's been a debate going on that for years, and they're not going to fix it. It's not going to happen. There's a conservative strategy because they don't want to break things, and you can follow the debate, but that's the strategy it's been fixed for system permissions. Previously, you could actually hijack a system. There was a paper called Pile-Up Flaws. They fixed that. But for custom permissions, it doesn't look like it's going to be fixed. Because, especially when you have apps from different vendors, you have Twitter and Facebook, and Facebook says, you need to install. I need to be installed first. And Twitter says, no, why? And they both need some sort of, if they want some sort of permissioning system to talk to each other, and they need to request those permissions, then they need to be declared. And that's why that behavior exists, and they're not going to fix it.
Right, any particular considerations or gotchas for push notification intent broadcasts?
For?
Push notifications intent broadcasts.
It's not an area I'm familiar with, so I don't have any. But I will look at it straight after this talk and see if I can dig something up. But I don't, sorry. Hi.
Would it be possible to find all the bad intents by some kind of automated script, regex, or something like that?
Sorry, to find all the
badly designed intents by some kind of automated script, some kind of regex or something like that.
Well, the easy part is finding all the intents and documenting how they sent. Whether they're badly designed or not, I don't see how you can do that in an automated way. And what we do when we do assessments, we look for these kinds of signatures, but then we have to check. We have to fire them off and check, see what they do, because the system's decoupled. You need to go through some dynamic verification process to see sometimes what the effect is. You can't tell it statically. So the easy part is finding it, but whether it's badly designed or not, that's not a step that can be automated easily.
I thought about, for example, mass scale assessment of, for example, all the applications on the App Store, which was recently made.
Yeah. So there are things in progress that do things on mass scale. They'll inspect the code, they'll inspect the manifest, and they'll just do really basic intent fuzzing. But then there's no observation as to whether that is a business problem or design problem. They're usually just trying to inject malformed intents and see whether it crashes or see what the behavior is.
Thanks.
Okay. Thank you.
think it's now 13:50, so given the dire warnings that I had in the emails about overrunning, I better start on time. Hi everyone, my name's Winston Bond. I'm here to talk about the new addition this year to the OWASP Top 10 Mobile Vulnerabilities list. So I'm actually late stand-in. So the pre-conference publicity was talking about a gentleman called Jonathan Carter, who was going to be doing this talk, but unfortunately he can't make it over from California, so I'm doing it instead. So that's a slightly good news, bad news story. The bad news is that I'm much, much less aware of the OWASP process and what went into the development of the top 10, and to, possibly some of the, if there's any historical stuff or sensitivities or anything, I'm much less conscious of that. The good news is I'm pretty well on top of the subject. I have been doing it I've been working in this kind of arena for about 6 years, so I believe I know what I'm talking about. But go easy on me with the questions, okay? So that's the introduction. What's our talk about? Or the talk is mainly just to try and go over what this addition to the top 10 is. It's what does it mean? Why does it matter? To some degree, what can you do about it? So I think the name of the vulnerability is lack of binary protections. Basically, it boils down to someone can take your mobile app and poke around with it or change it. So unless you've done something about that, you've got a bit of a problem on your hands in some circumstances. Oh, I'm going to pause. I found this when I was coming into some of these talks. Everyone bunches up at that end, so it's really hard to find a seat halfway through. So just come on past, Okay, so this is just a separating slide. There's not a lot to say. So we're just going to I'm going to talk in a little bit more detail about what this addition to the top 10 is. Or what the top 10 is. So the OWASP top 10 was updated in January with some different vulnerabilities, and I guess given a year of experience since the first OWASP mobile top 10 was announced, there were some ups and some downs. In the hit parade of what's viewed as important, or the relative merit or relative importance of these things, and was added to this extra category at the end was added, lack of binary protection. So some of these I'm not going to go through them all in great detail, mostly because I don't know them in great detail. So the top of the list, obviously, insecure data storage. If your data on your mobile phone is insecure, just like on any computing platform, it's easy to get at. Weak server-side controls. Some of these are kind of, I read through these, and they're very much the same as you'd have in a web application. A sort of thin client web app. You're worried about client-side injection and people, typing the right cryptic runes into a text box to do a SQL query on your database. So that's still there, and if you've written your mobile app just like a web app, that's going to be there. But really, they have the ultimate power on a mobile app. We're back in the thick client world again, where the client application does stuff. It doesn't just send key presses through to your web server. So they have the ability to make that mobile app send off its own SQL query if you've got that vulnerability. If they reverse engineer it, figure out how it works, change it, they can do what they like. I guess poor authentication. If your login process doesn't work, it's still not going to work in a mobile app. And in fact, in some ways, it's worse because you want it to be simpler in a mobile app. Typing in your 16-digit ID number and 7 digits out of 54 for your password and all the rest of it. That's very hard to do in a mobile app. Slightly defeats the purpose. So anyway, they're all important vulnerabilities. Some kind of coming over from the web world, and some like this one back in the issues you have to deal with when the client has a brain or is a little bit more than just a display. So what is it all about? So top of the list, basically, your mobile app is out there. It's on someone's phone. Probably half the people in this room are pen testers and know how to take it off your phone without an awful lot of difficulty. Even if you're not a pen tester, it's not that hard. So you can get it off. You can fiddle around with it. Have a look at what it's doing. It's not difficult, and it's not even expensive. If you're for Android apps, for example, all the tools to reverse engineer it are free. And then they can, your person who's doing that can then change that binary potentially, put it back together, load it back on the phone, distribute it through a different place, not Play Store, through a different app store, and it can do whatever it wants to do on somebody's phone. And the damage that causes, who knows really? It can be all kinds of different things. If it's your mobile, if you're a big company, it's your mobile app that gets cracked in some way, that's doing something weird to people's phones. In the end, the blame's going to end up with you, even if it wasn't your fault. Or it can be more directly damaging if someone figures out how to break the login system for your banking app and starts to steal money off people. It's real money kicking around. If you have some super secret algorithm running on the mobile phone, and someone can reverse engineer how that works, again, that might be bad. Or that probably is bad. Is there much chance of the super secret algorithm running on the mobile phone rather than locked in the data center? I don't know. It depends. Depends on who you are. There are circumstances where it might be running on the mobile phone. If you've got a phone app, I don't know, figuring out how you drive and working out your insurance premium, that's going to have to do a lot of stuff on the phone. It's not going to be telling a server, or it can't tell the server, every 3 seconds, what you're doing with the accelerator. So all of that stuff is there. It's open to being reverse engineered and fiddled around with, if necessary, by somebody. So that's the vulnerability. I'm running ahead of myself, aren't I? So what do these kind of attacks result in? So I guess one other thing that somebody might be able to do is if you have security controls that you've embedded into the thing to stop certain kinds of attack, they might be able to dodge them. So an obvious one on that is jailbreak detection. If you go down a route of deciding that your app is only going to run on non-jailbroken, non-rooted devices, then you are going to have to sort of toughen that up a little bit, because people are going to try to dodge it. They're going to try and cut it off. You're going to have, you're into a bit of a fight with the people who want to run it on a jailbroken device. Whether it's right or wrong doesn't really matter. There are circumstances where you probably would want to stop that, because if you're running on the jailbroken rooted device, it's kind of starting to open up the security model. People want the freedom to have the free copy of Angry Birds or whatever, but on the other hand, they'll be really cross when their bank account gets emptied. So that you have to stop people compromising the things you've put in there. You can have the sensitive information in there potentially. Whether there should or shouldn't be that sensitive information in that app is probably open to argument, and there's probably lots and lots of best practices that say don't put sensitive things in apps. Sometimes you've just got to. You can't avoid it. Or sometimes they're just there and nobody's done the right things to eliminate those vulnerabilities in advance. And then back to the same point, someone can, if someone is able to reverse engineer that app and take out some of the logic. If your mobile app is doing the stuff that stops people launching SQL injection attacks, it's probably a bad idea anyway. But if that's where you've put that that logic, someone might bypass it. Just continuing things. Oh, I guess other things. If someone uses your app to or repackages your app with something else in there, that's probably that is a bad thing. We've talked about reverse engineering on some applications being a problem. And I guess also, the reverse engineering step is a step in the road towards understanding vulnerabilities. So, if your mobile app is controlling what your server is doing, then understanding what the mobile app does is a good step towards understanding how to drive the server and make it do what you want it to do. Am I just repeating myself here? I am, aren't I? So, the last one, IP theft. We talked about that. Piracy, getting a free copy, cutting off the licensing. That's, in mobile apps, that's not generally huge. Well, it's there. It exists. You go to the Cydia store and you can get yourself whatever you like, really. But does anybody really care enough to do much about it? When you're talking about a 99p game, probably not really. But if you end up with a mobile app that has a significant price tag, then if you've got a sat-nav application for £100 rather than one, then all of a sudden stopping somebody pirating that becomes a bit more interesting. How prevalent are these attacks? I think there was an HP research effort that a gentleman outside was telling me earlier on was they looked at 1,000 mobile apps on a well-known application distribution platform for mobile apps, and discovered that most of them are vulnerable to an attack of some kind, and most of them don't do anything at all to stop you reverse engineering them or modifying them. So what those vulnerabilities are, I guess everyone is going to have its own vulnerability in their own different ways. Whether they matter or not, again, that depends on who it is and what it is. If it's the One Direction application, you're probably not that bothered, really. Pick the boy band of your choice. I'm not trying to promote anyone in particular. But again, if it is a movie player application for DRM protected movies, that certainly the people who sell the movies to you will be quite bothered about that, and they will want to make sure that they are as tough as they can be in protecting them. So again, what do people want to do when they're attacking these things? Same stuff we've already talked about. Bypassing the security controls that you've put in there. So, jailbreak detection, stuff to keep the DRM from being bypassed or finding the keys inside it. Potentially adding, somebody adds their own code, redistributes it. Repackages your app as their own. So I guess you can, where would you want to do that? I guess if you wanted to produce your own Flappy Birds clone in the easiest possible way, you'd take the original one and repackage it. And then, stealing information about users, this is a sort of classic web vulnerability and something that people, are concerned about. If you've got a modified version of an app that's then sending off user credentials off to your own private server somewhere, then that's not, you as a big company whose app is being attacked in that way, that's going to be a bit of a problem for you in the long term. I can't remember, I wish I could remember the details, but I read a report a couple of months ago about, a mobile app being attacked through one of the kind of vulnerabilities we're talking about here, to redirect, to send off login credentials off to another server. For no apparent purpose, but it's a bad thing, isn't it, if your login credentials are getting sent somewhere. So this is trying to kind of show different areas of risk that you have, business risk. Is someone going to steal your money? Operational risk, is someone going to break your system? Technical risk, I guess that boils down to, is someone going to work out how your software works and steal it? And you can kind of separate those into two parts. There's a confidentiality side to it and an integrity side to it, which again, to boil it down even simpler terms, one is, the confidentiality is one is understanding how your code works, and the other one is changing it. Which are two sides of the same coin. It's kind of hard to change it until you understand how it works. Ask anyone who does maintenance on big company software. But it's, so the first step, I'm going to talk about these in reverse order. But to code modification, what are the risks, what people might be doing? So repackaging it, changing it, redistributing it. Method swizzling. Anyone heard of method swizzling? Excellent. That's good. Some, at least. So method swizzling is a wonderful thing. It's a lovely feature of the Objective-C language where you can redirect what things do at runtime without changing the code. So, as a developer, it's a great thing. If you're, and it's one of the sorts of thing that people like about Objective-C as a programming language. From a security point of view, it's an absolute nightmare, because someone can take your lovely jailbreak detection routine and they can say, actually, I don't need that one anymore. I'm going to use my own that does nothing at all. And you can do that at runtime without changing the code for the software. You do have to be on a jailbroken phone to do it, though. Security control bypass, so that's, if you've got your own stuff in there to, check your environment, check that no one's changed anything, make sure it's all legitimate, people are going to try and get around that. I guess that this is the same, jailbreak root detection disabling is in the same category, where people, go for it. That's all right. So yeah, people will also, will try to, turn off your jailbreak detection because it's their right. Presentation layer, so making your UI show different things. Key replacement, or I guess the first step against someone finding your key is to use an algorithm where even if they find the key, it doesn't matter. The trouble then, so you're into public key. The vulnerability there is, well, maybe they'll just find your key and put one where they already know the other half. So they're not going to work out a private key from a public key, fair enough. But if they already know the other side, they can just replace the one that's buried in your code, which then lets them do a man in the middle or something like that, again, on you. Yeah, go for it. So there are, there's a number of risks. I'm sure there's others. It's basically if you can modify the app, you can make the app do anything you want. And what anything you want is up to you, and whether it matters or not, again, depends on who you are. So this is the swizzling example, where here's a bit of Objective-C code that basically says there's a method. I must remember the word. Sorry, I'm an old-fashioned guy. I call them functions, but there's a method which it takes two parameters. One is your username and one is your password, and says whether you can log in or not. It's probably not a very wise piece of design anyway, but it's an example. So somebody could come along and just replace that whole thing and say, yeah, we're always going to be happy. As far as the app's concerned, we've always logged in. The world's good. The standard runtime on the phone isn't going to do anything to detect that or stop that. It's designed that way. That's what it's for. The next one, similarly, here, this is, again, another Objective-C iOS example where someone, goes through and finds your function that says, are we jailbroken? And, we'll override it. So, first off, they probably just swizzle the whole thing out of the way so that it's always going to be happy. If they don't do that, they could just make it return true all the time. Sorry, true, false, false. You'd want false, wouldn't you? So it's always going to be, it's always going to say happy. Although to do that, they'd then have to be, that's changing the code. They'd have to re-sign it to make it work very far. In any case, this string here is going to be blindingly obvious in the code, so they'll be able to find that in the code, understand how your simple jailbreaking detection works, and then know that if they rename cydia.app to something else, then you're never going to find it. So there's this piece of code, which this is source code, but you could get that back off the binary on the phone fairly simply. Even if you don't go and buy a decompiler, you could get the assembler code, and you'd understand that really quite quickly. The other side of this is the reverse engineering part. So really, this ought to come first, because this is the first thing you'd have to do, is get your app, figure out what it's doing. So what are the risks? So there's the method signatures. So again, actually all of the, so either Java for Android or Objective-C on iOS, all the method names and the parameter names and just what it looks like, or what your well-engineered software design says about itself, is all exposed in the binary. So you can just read that. Go ahead, just go to the other side. It's probably the simplest. Don't worry, it's fine.
It's not a movie.
Yeah. So yeah, all of your, all the things that as a well-trained software engineer you do by giving things nice, friendly names, that's all there to help someone understand your binary, unless you do something about it. API monitoring, so people will be able to figure out what you're doing by looking at what system APIs you're calling and monitoring those at runtime potentially, or changing, redirecting them at runtime if necessary. Exposed data, so again, the data and the strings and the crypto keys and all the rest of it that you have embedded in your binary are there for anyone to find and have a look at and do what they want with. Decompilation, trivially simple on Java, .NET, a bit harder on Objective-C and C code, but still doable. And you can certainly analyze it to work out what's going on. I guess, application decryption, that's I really should have put that at the top. Yeah, so that's the first thing you have to do. Application packages on iOS are encrypted. So if you just take the thing that iTunes has stored on your disk and try and have a look at it with a disassembler, you won't mean anything because it's encrypted. But it's fairly straightforward to get it decrypted and get it back off the device again. So that is the first step. Just because the phone vendor encrypts the binary for you doesn't mean you're safe for very long. It's really, there are I guess that's the thing with any standard technique. You know, every single app is encrypted in a similar way, so there's a standard way to unpack that. Just like in, I guess, the web world, you know, everyone uses the same 4 or 5 browsers, and it used to be everyone used the same one browser, pretty much. So, you know, once you'd worked out how to attack that one, you know, it's toast. The same with encrypted binaries. You know, it has to run on the processor in the end, so there has to be a way to decrypt it. So, you know, we've mentioned this. You know, if you've got an embedded cryptography key in your application, it's probably something you don't really want people to read. You know, and you can say it's a dumb thing to do, and it probably breaks 1,000 guidelines of the thing to do. But sometimes you can't avoid it. You know, if it has to work online, offline, it can't get something from somewhere else. You don't want it to necessarily be asking the user for a piece of input, but you still want to keep some data, you know, avoided, you know, hidden from casual, you know, someone kicking the tires, just having a look around. It might be hard to avoid having some kind of key in there. So, you know, you want to hide those, or you want to stop someone reverse engineering those. Yeah, oh no, it's not on this, but, you know, a similar an example. You know, I was looking at a binary, at an application that I use on my phone, and it's not a security critical application, but I was having a look around in this just out of curiosity, frankly. Probably shouldn't have done, but there we go. And you have a look through this code. It's done nothing to hide anything in it, and they've got the, you know, fairly standard, as people do. They put the test server login on there, you know, embedded in the code. That's great. And then you look down the list and you find that the developer's personal login is in there as well. You know, and then it turns out this guy's a security consultant as well. You know what? That's really not a very clever idea. You know, if I was that bothered, you know, I could log in as you. So, you know, those sorts of things people do, and you want to be able, you know, I guess, you know, by design you might have to put a crypto key in. There might be stuff that's just left in there through, probably laziness is probably the best description for it. You should probably kind of do something to mitigate someone, you know, finding that, you know, so easily and making use of it. Debugger detection. So, you know, anyone trying to reverse engineer your app is going to try and attack it, or particularly if they're going to try and change it, they're going to try and attach a debugger to it. It's very hard, actually, to stop somebody ever attaching a debugger to something. It's really, really hard. But you should at least try and make life a little bit difficult for them by doing some basic checks for debuggers at the standard entry points and some places in the UI. So this is the. So we talked about, you know, some ways people are going to attack your code based on, you know, reverse engineering it or changing it. I think that this now talks about, you know, some other things or practical things you can do. So, you know, I guess it's fairly straightforward. You know, you know, if you do good things, you know, implement or use good algorithms. So if you're going to do jailbreak and root detection, you're in for a bit of a battle. But you know, you can choose algorithms which will work. You know, do some checksumming on your code. So that if, you know, the signature checks that built into the OSs do some checksums for you. Basically, when it loads, it has a look and says, "Has anyone changed this?" If they've changed it, the signature is going to fail. So that's a very basic check at load time, but it only happens once. You know, I'd suggest, or it's a good idea to do a bit, you know, inside your own code as well. I believe certificate pinning, basically that means, you know, making your crypto keys only work on this device. So that's about cryptography design, about you know, and I guess well, it is basically about cryptography design and stopping people understanding how that works, if you can. Debugger detection, again, good thing to do. And all of this stuff needs to be protected from reverse engineering or code changes to the degree you can, which is to a very large degree. Yeah. So yeah, this is a catch-all. This is your mobile app must be. In truth, it's probably if you care, your mobile app must be able to do this. Again, there's lots of mobile apps out there for different things, doing different doing different things in different ways for different people. And for a lot of them, nobody's that bothered probably. But if it's starting to if it gives a way into some user database, or it's storing stuff there that's user data, or if it's controlling money or something that's worth money, then you really need to start thinking about securing it. So you need to stop someone reverse engineering it for a start, because that's just the very first step they're going to take if they want to do anything to it. Then you need to look at it at runtime, not just when the OS loads it, or look at your code at runtime, and potentially some of the other files around it as well. I can never remember the alphabet soup of p-lists and whatever else there is. All the different properties files around the app that can control what they can do, and it needs to react appropriately. So you need to make some decisions about what you're going to do if you find out that someone is trying to attach a debugger to it. What do you want? Do you want to log them out? Do you want to, just give them a nice friendly warning on the screen? Do you want the program to crash? Do you want to send the heavies around? It's up to you. What do you want to do? So yeah, there's some choices you as a developer have to make. Defense in depth. Whatever you do in your code, it's only software in the end. So if you have a checksum in there that's checking whether it's whether someone's changed the code, it boils down to a branch in the end. Something's going to say, is it right or is it wrong? So once they've found that, they can remove it. So really, you need defense in depth. You need lots of different things, all looking at each other, and all looking after each other, and don't rely on one single control to stop someone attacking your app. I need to move off this slide because I'll get in trouble because it's slightly close to what Arxan's product does.
Doesn't stop every other presentation.
Okay, that's fine. I'm sorry. I read the presenter agreement, and yeah, and I know that my children will be harmed if I say the company's name too often. So anyway, yeah. So conclusions: binary attacks. They are quite common, quite easy to mount, and the majority of mobile apps, I'd say that the large majority don't do an awful lot about it. Now the lack of binary protection is in the top 10. I hope it's going to move up the hit parade in 2015. As people realise it's a major threat. To stop it, as a developer, you'll have to do something about it, because the things built into the platform don't do it for you. They do some things; they're very good at some things, but this particular attack vector, they aren't going to do anything about. This part I'm skating on very thin ice because I don't really know what I'm talking about. So other mobile projects. So there's a link there for the OWASP top 10 that goes through that list that we had at the start, talking in detail about each vulnerability on the list. I think that's, and I guess this is the more details on this particular subject on the OS website. So that is the end of my presentation. I think I'm running a little bit early. But, so has anyone got any questions? Make them easy ones, please.
Thank you. So you did mention if the app does anything sensitive, and you need to start thinking about how to secure it, which I couldn't agree with you more. Then all the examples you provided on why you should think about implementing this control mainly rotate about client-side validation or hard-coding secret, which, as you will agree, is probably you should avoid doing that at the first place.
Sure.
So my question to you will be, it seems to me this control that somehow ended up in that mobile top 10 risk is about security through obscurity. And it's not necessarily a good thing because it hides the vulnerability that you have in your app, and you should remediate those vulnerabilities instead of trying to hide them. Especially just the last bit, especially that technically you're just making it harder because technically it will still be possible, since this is client-side code, to actually be able to see the code.
Yeah, I can see what you're saying. That in an ideal world, you wouldn't need this. But there's a few things that kind of make it a less than ideal world that, that there is the one that, there's been lists and guidelines and scanning tools and all sorts of things that will tell you how to write code for a long time, but problems still exist. That's the kind of reality, I suppose. Then you're also dealing with, you've got mobile developers who have to get their app out in, 3 weeks, 3 weeks is an exaggeration, but a few months to get the project, going, and their focus is on, just making the UI work and joining everything together. And they might be sloppy, almost certainly will be. And then there's sometimes it is just necessary to do things, or you have something that you just, however good your design is, you need to stop people understanding what's going on there. Because, I don't know why. Oh, sorry, I need to think of a good example. It's hard to think of a great example of, where somebody, just in the end, there is going to be a vulnerability there. That DRM player is a great one, So in a DRM player, there's some cryptography happens, and it just turns out that the private key has to be in the player. So, you've got to hide the private key and stop someone understanding that, stop somebody then playing around with the app, finding the symmetric key that's used to encrypt the video so they can dump it. And, in a perfect world, all of that stuff would be handled in hardware, and there would almost be no software involvement in the process. It would just get taken care of for you. But that's not how things are. The mobile platforms are designed how they are. The user APIs are what they are, and they don't allow you to just take all that stuff away and do it by magic. So I agree with you that in a perfect world, you wouldn't need any of this stuff. I think in the actual world, there are imperfections around that mean that you have to. Okay?
Thank you.
Okay. I'll repeat the question. That's okay.
Yeah. Okay, thank you. What's the difference? It's more a provoking question, excuse me. A little bit under the hood, it seems to me like you're doing license protection, or part of it is license protection, or license violation protection. So what's the difference to standard desktop or server applications? And
what's the difference between this and standard desktops? Not a great deal, honestly. A mobile platform binary in the end is a lot like a desktop platform binary. I think the difference comes in where it's used and how it's used. A mobile app, for all the noise that people make about not trusting mobile apps, you really do. You spend a lot more time with your mobile and trust your mobile phone a lot more than pretty much any other piece of technology. It's there when you go to bed. It's there when you wake up. It's there with you all day. You do your banking on it. You do all sorts. You keep in touch with your friends on it. It's your constant companion. So people are growing into the habit of, you type a few digits into it, and it identifies you as you, and you're into your bank account. Whereas you don't have that in a Windows PC, for example.
Well, of course.
Picking at a brand.
Well, of course, you have in the Windows world, you also have some kind of sites which offer downloads of Microsoft whatever. And they contain malware because people just whole operating systems. Isn't that kind of reinventing the wheel? I mean, there wasn't there on the desktop. It seems to me, I'm not an expert there. It seems there isn't really a solution. I don't know. I can tell. Maybe you can go this far, but you never reach. It's an arms race.
Sure. I mean. To dance that very thin edge, that I have to dance on at an OWASP presentation, you can do all of these techniques on desktop platforms as well. And if you have an application where you have this kind of sensitive stuff, or you want somebody to stop somebody cutting off your license protection, it can be done on desktop platforms just as much as on mobile. But the focus here is on the mobile vulnerabilities and the mobile top 10.
Thanks.
You get some exercise.
You can repeat the question. I'm doing some exercise today. That's good. Now you don't want to ask anything, right?
I forgot about that.
Excellent. Phew.
Do you see, as a partial solution for cryptography to use TPM? Are you aware of the TPM module?
Yeah.
Do you think that is going to improve, or because then technically you can put your keys on a silicon chip, then it will be almost impossible for another app to side channel.
Yeah.
Spoofing on, yeah. Do you think that's going to solve most of the problems, or?
Technically, it's a great idea.
Okay.
Love it to bits.
Okay.
But TPMs have been in PCs for 10 years.
Yeah, okay.
How many of them actually get used? And
yeah.
I don't know anything about roadmaps and so on, but on an iPhone or an iOS device, you can't get to the. I bet there's hardware cryptography in there, but you can't get to it in a user app. Android, I think, has started to let you, as of KitKat, do some things down in the hardware layer. There are all kinds of practical business issues around it as well, where you have to have multiple partners playing together to give you access to that hardware to let you put something on there. It just it's never really taken off. So whilst in principle it's a great idea, so far it's never really gone anywhere. And if you were starting today, you'd still have to assume that your mobile app doesn't have access to that, because it probably won't on most of the devices it bumps into. Give it a few years and you might be able to assume it's there. But I'm not sure that clock has started ticking yet, because it's only on it's only on the very latest Android devices that you can get to hardware crypto right now.
Yeah, there is one on Windows Mobile.
Okay,
I'm telling you. Do we have some proof of concept for even authentication? So,
right.
But yeah, I can't say when it will be available. But the idea is to give an API for developers so that they can keep the keys on that one.
I think it's a great idea, and if Windows Mobile is going in that direction, I think that's that's fantastic. Okay. You just need to drag everyone else along as well.
Okay.
Thanks.
Cool.
Anything else? I guess we're done. Thank you very much for listening, everybody.
the room number is swapped. So I'm Hamil Shah. I'm a founder and director of Xsecurity and a key member in Bluenfi Solutions, a professional services company into application reviews based in India. I'm also on an advisory board for some of the companies like Security Exposure and whatnot. In the past, I tweet at Xsecurity. So pretty much the talk is going to talk. I'm going to talk about the how do you actually automate the mobile application reviews. So who doesn't have mobile apps today? Pretty much. Yeah. So if you look at the book, the smart storage scanning, the description about smart storage scanning is actually written in HTML5. So it is swapped. So the topics which I'm going to cover is actually written into HTML5, and the HTML5 stuff is over here. So it's swapped pretty much. Yeah, so so pretty much every company out there has a.
Headline is correct for your lecture.
Sorry?
The headline is correct.
The headline is correct. The component, the description is actually swapped. Yeah, yeah. So who doesn't have the mobile apps today? Pretty much every company has a mobile app, or they are making one these days. So if you look at some of the industrial stats on which platform has been leveraged more, is if you look at, this is in stats from IDC. If you look at the Android is pretty much leading the way with 81% of the devices today leveraging the Android platform, and then the following is iOS with 15.2%. So if we just sum both of this platform, it's pretty much more than 95% of the 95% of the coverage onto mobile platform. So then pretty much I can say you can just avoid the rest of the platforms, because then there are very less users on those platforms. The OWASP top 10 stuff, I'm not going to talk about the OWASP top 10 because there has been already a talk about OWASP top 10. But if we quickly look at the OWASP top 10, the insecure local storage has been leading pretty much almost 98% of the application has insecure data storage vulnerability. We do this consulting services, and almost we test like an 50 to 60 application a month. So from our stats, and we were part of the OWASP top 10 project as well. So from our stats, if you look at it, the local storage pretty much somewhere between 95 to 100% of the application we test, something is stored into the local storage. So you pretty much can see you pretty much can see that almost all application is storing data into the local storage. Then there is an information stored into the log file, which is shared between all the application. The copy paste, the privacy issue, the copy paste has been not disabled. We pretty much find it in almost like an 85% of the application. And then the cross-site scripting and the SQL injection has been discovered at lot of application as well. So let's look at some of the enterprise cases on what we have been finding. So this was a typical Android e-commerce application where the Android e-commerce application allows you to perform the transactions. So in this case, we found that credit card and private data information was actually stored into the local storage, but they were encrypting the file. Now, in Android, what they did is the encryption and decryption was happening on the client side itself. Now, the encryption key was actually part of the code, because he has to keep the developer has to keep the code, the encryption and decryption token in as part of the code. Otherwise, he will not able to encrypt and decrypt the stuff. So by decompiling an Android application, it was possible to get an encryption and decryption token, and then you can pretty much get an access to the file stored into the local storage. And then they were leveraging a web view control, so it was possible to perform a cross-site scripting attack onto Ajax And then on the server side, we found we did a SQL injection over a JSON. So pretty much, if you look at all the attacks, so on the this is an example where it was a banking application. So your banking application would have a functionality which lets you see your past statements. Now your past statements are actually in a PDF format. So when the user actually clicks on past statements, the PDF gets downloaded, and then your application has to, your developer has two options. One is he writes the PDF reader himself, or he leverages the OS and give a control of PDF to that OS default PDF reader. Now, when the application actually hands over the control to the PDF reader, application doesn't know when the PDF has been closed. So there is just no way an application can remove that file. So here it was, and then your statement would have all the transactions information, your social security numbers, and all that information. So it was stored into the local storage. And then in iOS, the default behavior is to cache all the request and response in a file called cache.db. So the cache.db file actually had all the request and response, including your login request. So ideally, you should be removing the cache.db file as well. This was a social application. Lot of people leverages HTML5 these days for mobile to have a common code base for all the platforms, be it an Android or an iOS and whatnot. So this was an example where it was a social application, social media application which leverages an web view control on platforms, and it was possible to bypass, and this application had functionality that it only allows you to have it installed on one device per phone number. Now, it was possible to if you just copy the entire local storage from one device to another device, then entire account was actually replicated to another device, and then it was possible to leverage access the application on both the devices. So that pretty much hurted the company, because it was a direct financial impact to them, because now they were not getting money for every download. The screenshots were stored in a local storage, which is again in default OS behavior. On the presentation layer, it was possible to do cross-site scripting and SQL injection, as they were leveraging in web view control, and they were sending that information in a plain text. They were not leveraging SSL. So if you do in postmortem, pretty much all the application had one vulnerability in common, which was a local storage. So, and then the server side and the logical issues were always hard to find, but it's always have the biggest impact, as we all know. Lot of time the question comes like, why the developer actually stores the information into the local storage? It's actually to provide an ease of information, ease of use for the user, or to gain in popularity. Or in mobile, everybody wants to achieve activity with a single click. Just a minute. Yeah, in mobile, everybody wants to achieve a stuff with a single click. So, and you want to achieve the decrease. You want to achieve you want to decrease the transaction time, and that's why you want to keep the information into the local storage. I'm not saying you should not keep the information in local storage, because the security has to always balance with the business requirement. And if you do not, if being a developer, if you do not store the information into the local storage, you are not achieving the business requirement. Security cannot overcome the business requirement. What information you usually find into local storage? The authentication credentials, the authorization tokens, your financial statements, your credit card number, your private information like your social security numbers, your social engineering sites, your Facebook and Twitter accounts, your owner's information, where I'm staying, where I'm living, and what is my phone number, and who is my wife, and what my kid's number is, and whatnot. And all the request and response which is sent from the client to the server in a typical iOS application. So if we look at some of the demo, so this is a first example is where so this is an Android application where it's an e-commerce Android application which allows the user to perform in standard like an purchasing stuff and whatnot. So this is a bookstore. I'm entering my credit card number into the application. To perform the transaction. Now, being a user, when I do this, I don't know what's actually happening behind it, whether it's storing it or not. But if you go back and look at the application directory, the application directory actually contains a database file called info.db, which actually got the credit card information stored in a plain text. This is just an example where I'm storing the information in a plain text, but a lot of time we have seen an application which actually does a different kind of encoding or hashing the information before storing it. So, and that's why we have like a poor cryptography implementation in one of the OWASP top 10 list as well. If you look at the server-side exploitation from the mobile application, on the same application, when I click on the app, when I click on the any book, it actually is sending a JSON request. So here, if you look at the content length is 886. But then if I change the JSON to have or 1 equal to 1, I'm going to get all the results back. So now, if I hit go, the content length is 6,591. That pretty much proves that it's all the data. Now, a lot of time we get a question that XSS is not exploitable in terms of mobile. Now, here is an example how does an XSS can be exploited. So again, this is an HTML5 application where I have a search page which has the XSS. Now, you get a pop-up. Now, what I have done is I have written in a small node.js script. What I have done is I have written in small node.js script which actually reads the file from the local storage of that application. So I'm going to start the node.js script over here. So I started my node.js script, and then I'm going to inject the attack vector, which will send me the entire file onto my node.js server, which is running on a different machine. So it says client has been connected. Now if I go to test.txt, it has all the data which was stored from the local storage of that particular application. So with the XSS on the mobile, you can actually read the information from the local storage as well, which has probably the more impact than the web, where the user probably needs to click on the XSS link before you can exploit it. So what are the different threats? A lot of time the company says that we have MDM in place. We don't allow any jailbroken device or a rooted device from our MDM. Or we have strict policy enforced through an MDM which does not allow user to jailbreak the device, or which forces user to have a password protection. Now, so the questions are, what attacker can do? What attacks are we talking about? The privacy, it is mobile. At the end, the mobile device is prone to be a mobile. So the different exploitation scenarios are, first of all, the physical theft. in just last 1 year, there has been more than 1 million instances in just United States where the smartphones were stolen. The temporary physical access, even I can get in access to your device for 5 minutes on an iOS device. I can get the data using a tool called iFunbox, or in an Android, I can just install ADB over Wi-Fi to get in to access your device remotely. You have a lot of malware and malicious application, and just in a recent study performed by Virginia Tech University, Google Marketplace itself has like an 8% of the application which does a malicious stuff. It's the lack of standardized security review process. It's like, I'm going to talk about this as well. And then there is always a chance that the attacker can jailbreak the device if he gets in physical access to it. What are some of the other challenges? It's a review process. We all know that Apple reviews their application before coming into App Store, but do we know what exactly they look for? We don't know. It's not transparent. It's very time consuming as well. So let's say I'm a developer and I have found a vulnerability. Now I have fixed it, and then I have to send it to Apple so that Apple can release it. That particular fixing the vulnerability and sending it to Apple and releasing it takes actually good 3 to 4 weeks of a time. Google just recently started it. Google recently started reviewing the application, but again, the problem is same. It's very hard to catch up for them because there has been already more than 1 million application in Google Marketplace. Not possible in BlackBerry at all, because BlackBerry actually has started that they will natively support APK files. So now you can use any application from Google Marketplace on your BlackBerry devices. So how does BlackBerry is going to control what applications have been reviewed or not? They probably don't have any control over it. The another challenge is actually frequency of updates. If you look at pretty much on the web front, if you look at the life cycle of web application release, it's either 3 or 4 releases a year in terms of web application. If you look at the mobile application release cycles, it's very fast. If I show you some of the stats, this is the stat for 2013 where Facebook, so I don't know whether you guys can see it or not, but Facebook last year had like 19 releases for iOS and 34 releases for Android. JP Morgan Chase Bank had like 9 releases for iOS and 2 releases for Android. eBay had 9 and 4. Amazon had 10 and 3. So pretty much if you look at and WhatsApp has like 24 and 54. So pretty much every 4 days you have a new version of WhatsApp in Android. So if you look at the release cycle, it's so much higher compared to the web application. It's even tough for any company to review the applications during that time, or review the entire application or even a partial of the application, because the pen tester will find the stuff, then the developer needs time to fix it and all that. When we are looking at even this 10 applications, pretty much you are talking about every release a month. So how do you review the Android application? Android natively supports like 3 types of storage: the internal storage, the external storage, and the storage in a shared preferences. The internal storage is basically as part of the data directory itself. The external storage is storage into the SD card, and then there is something called shared preferences. Now shared preferences is actually a file which is shared which can be shared with a different application if the other application has permission to access it. How to test? Is it very hard to test an Android application? It's very time consuming, because typically when you are doing a manual review in terms of any Android application, what you need to do is you need to capture the different state of the application. So you install the application, take the state. Then you open the application, log into the application, take the state. Then you perform another feature of the application, you browse through another feature of the application, you take a state. and then you log out the application, you take a state of that, and then you close the application and you take out the state of that. And then one has to compare each of the state to find out what has been stored at what functionality or what level into the application. So if I can show you that, so this is an Android application. I'm trying to perform an review called internal storage demo. So I go to that directory. I do ADB pull. So I just install the application and took a state back of that particular directory. And that has the token file which has the value 28782. Now, so this is like you are copying everything and then you are reviewing stuff, and then you open the application. You take a backup of this. Say backed up. Then you open the application again and do an ADB pull again. So now I enter the credential and log into the application. I have to do an ADB pull again to get the dump of after login. And now you start observing the data. Then you need to, so let's say my application has 10 different functionality, then I have to do this 10 times, and then I have to compare each of that to come up with a conclusion whether the application is storing information into the local storage or not. It's very time consuming. It's tedious. It's very tedious. It's not human who would do it accurately every time. It's prone to be false positive because if you're doing it repeatedly 10 times or 15 times based on the functionality of the application, you will end up overlook some of the information, and you will not find stuff which is there into the local storage. So can we automate this? Yes, in terms of Android actually provides you an API to monitor the file system. How many of you have used like an FileMon? A classy FileMon tool from sysinternals was very handy when you're testing a desktop application. Similarly, we have written a tool called Droid. It leverages an SDK. No hacks, nothing is required. It's an SDK code. You install this application. It monitors a file system. You can write filter on what directory you want to monitor. It can save your last 5 reports. You actually don't need a mobile device at all. You can run it in an emulator as well. And it's very easy to run. You just hit in one click. That was the previous version. The new version, which I'm launching along with this talk, if you go to the website, you can download it. So earlier, one of the challenge was, a lot of time the application creates a new directory at the time of run. So when the application is running, if it was creating a new directory and storing the information as part of the new directory, the tool was not finding it. The new version now finds it. And then the permission has to be assigned manually in previous version. Now the tool actually, you just select the application and the tool will assign a permission to that directory. So let's look at an FS Droid in action. So on the left hand side, on the right hand side you have a previous version where I'm, let's say, monitoring the bookstore application. Before I hit start, I have to assign a permission. So here you can see that there is no permission for com.bookstore. Just to make it easy, I just assign like 777. So now now everybody has the permission to look into that directory. You fire up the FS Droid again, and then you just hit the start button. Now if I minimize this and then fire up the bookstore application and perform the different operation in bookstore. Now if I go back to FS Droid, it will show you what directories it has opened and what directory it has closed. So now you know where to look for the information. Now in the newer version, we have simplified this. So in the newer version, when you launch it, when you go to config, it shows you the list of application. You just select the list of application and it assigns the permission. You hit the start button and then perform the operation. It will now actually show you which file has been modified as well. So this is an improvement into the engine where over here, if you look at this, it shows you that this file under data com.bookstore cache, WebView cache, Chrome staging is closed without any write. So now you know that application is modifying or writing into which file. So that is the, now it's more like an complete file monitoring rather than just giving you the hints. In terms of iOS doesn't provide you any such APIs to monitor the file system. So we came up with a different idea. iOS basically have like two type of storage, internal storage and the keychain file. Nothing new than Android. Pretty much you just go through the different files and directories and to find the information, and that's all the methodology is for the manual review. So on a non-jailbroken device, the methodology is something different. So if I show you a manual testing for the end, forward into the local storage. So I SSH into it and then go to this application directory, find the stuff. And on the non-jailbroken device, what you need to do is there is a utility called iFunBox. So here, I'm leveraging an iFunBox to dump the data. iFunBox actually can dump the data even if the device is locked as well. So over here, you can say that the test iPod has been connected and it shows me the list of the application installed into my iPod. And then, first of all, I install the application using an iFunBox. So the application has been installed. So now, if I click on that application it will show me all the directories and files. You can pretty much copy the files from you can leverage the iFunBox to get an access to the local storage. Can we automate this? Answer is yes, using an iApplyScan. The current version of iApplyScan requires a jailbroken device because it actually connects to the device while performing an analysis. The existing feature, the previous version's feature is it can look for a sensitive information. It can tell you whether the particular file exists or not on a particular directory. It can download the file if you want for a further analysis, and it can run any third-party external binaries like a keychain dumper or anything or a cookie.binary cookie file to get an output of those third-party tool. The new version actually we added the poor cryptography detection. So now if your target application is storing the information using any encoding mechanism or a hashing mechanism like a base64 hex, URL encoding or HTML5 or gzip, or in terms of hashing it, if it is leveraging MD5 SHA. So you enter the credentials, it connects to the device. You select the application you want to review, and then select the location where you want to download the files. Enter the text which you want to search for. if you want to look for any particular file, if you want to see, let's say, whether the database file exists or not and whatnot, you can enter that and then hit run. That will show you all the data. So this is the previous version. Now if you look at the newer version of iAppScan, the newer version has more features. So now you connect to the device. You connect to the device, select the application name you want to review. Same, select the path where you want to download the stuff. Next, enter the text you want to look for. It also supports the regular expression, so you can enter the regular expressions as well. Select the encoding and hashing mechanism you want to test for. And then if you hit run, it's going to find all the information. So from the previous one, this application actually stores base 64 encoding, so it was not finding the word Jill, if you have observed the last time. Now it has been finding the Jill has been stored into one of the file as well as base 64 encoding text. So now you know that the application is doing two things. One is leveraging the poor cryptography because they are encoding the stuff rather than encryption. And then you also know that this particular information has been stored locally. So now I'm going to, let's say I want to use the same config file, the same configuration for multiple scans. I can enter all the details and then save it for the later purpose. So there is a feature called save config. So let's say I want to just test that encoding. I don't want to try all hashing stuff. And then before running, there is an option called save config. So if I hit the save config option, it stores the information into the XML file. And then if I open the iAppScan again, it lets me load the config. All the information would be there. So this pretty much becomes like a routine for my reviews, where now I don't have to enter all the text and everything again. All I do is load config. So if I just load the config, all the information would be there. So with both of this tool, we are trying to cover 4 different OWASP top 10. Insecure data storage, security decision via untrusted inputs, broken cryptography, and sensitive information disclosure. So out of 10, 4 of the OWASP top 10 attacks can be tested with this tools. The tools can be downloaded from our website, espheresecurity.com/resource tools. The other tools called dump Droid, check debuggable, and an app code scan, which is in like a semi-automated manual, semi-automated code review tool. You can find that as well. Any questions you have? Sure.
We can try with this one for you, and sure. Thank you. It's switched off if you want to switch to.
Is it on? What are the benefits of knowing where the data is located?
So when you are doing a penetration testing, one of the checks is what information has been stored or at what places, because you are testing for the what risk you are exposing from your application. So as part of the testing, you would perform a test against what information has been
what
stored
an attacker can do with these?
Sorry?
What an attacker can do with this information?
What you can do with this information?
The attacker.
What attacker can do, that really based on the information you find. Let's say in your cache.db, I found a username and password.
As far as I know, only the application that created the data has access to them in the Android.
Yeah, so that's why I don't know whether you look at the slide or not. There were a slide how the attacker can exploit it. So let's say I'm an attacker and you are a normal user. Let's say I get an access to your phone for a temporary purpose, let's say for a 5-minute or a 10-minute. I can hook that to my phone or hook that to my laptop, get all the data out of your phone. You won't even notice that, and I'll give your phone back. And then I can use your information to become you.
Oh. Yeah, that's rather rare.
Or, so that's one of the case. The another case is, let's say your phone is stolen. I get a permanent access to your phone.
It's a rather rare occasion, I think.
Sorry?
It's a rare occasion, I think.
It's very rare case, you think?
Yeah.
Okay. Then the number is pretty high actually in terms of smartphones. Very high compared to the classic phones. So you're pretty much questioning whether we should be worried about mobile application security or not, because if the attacker cannot exploit it, why should I worry about it? Yeah. So in terms of Android, let's say I don't need an access. If you are using an Android device, in the recent study, there has been 8% of the application into the marketplace itself, which is the malicious activity. So let's say you have some application, you install some application from marketplace itself.
I just thought that the other applications, malicious applications, don't have access to the data that the other application wrote. That's what I thought.
Sorry, I didn't get your question here.
I thought that malicious applications don't have access to read the data of the other applications.
But there are certain areas of the application. So let's say a pasteboard is shared amongst all the application. Or there is something called shared underscore preferences directory.
Only where they share them.
Sorry?
So it's exploitable only where they share this information via their shared directory.
OS itself, yeah, to root your device, yeah.
This way, yeah.
Or let's say you have a copy paste enabled into sensitive fields. Now, when you hit the copy button, that gets written into the pasteboard, which is shared among all the application. A malicious application can just monitor the pasteboard to get an information to all this access, to get an access to all this information. Similarly, in Android, there is something called shared prefs directory. Now, if you store something into shared underscore prefs directory, there are 3 different types of permission. And the worst thing is, by default, the permission is allow all. Ideally, allow none should be the permission, but by default, the permission is allow all. So if you write anything under shared underscore preferences, and if you do not assign permission to it, then every other malicious application can read that data as well.
Thank you. I got it now.
Yeah. Sorry? 5% physical theft everywhere in the world.
I was going to say that's a lot of smartphones, if you think about it. No, my question is more related to the data. You said some applications don't know when they've closed, so that they don't actually tidy themselves up. Does your tool do anything looking at how long that data resides with, some applications may be a bit more savvy and actually clean themselves up afterwards. Does your tool look at how long that data resides in the local storage? So, it may write a piece of information, then 30 seconds later get rid of it after it's been used? Or does it just assume that it's just looking for written once and then just doesn't look at what it states afterwards?
No, so current version does not do it, but that is the feature we are developing as we speak.
Okay.
Yeah. For iOS. In terms of Android, yes, it does, because Android is pretty much the FS Droid is a file system monitoring. So when you're actually going to delete it, it is going to capture the event that, okay, you have deleted this file at this particular time as well.
Does that tie it back to the original application that launched it? Because obviously you could have a malicious piece of software that says, hey, I've just got that piece of information, then deletes it from the original application that was using it.
Yeah, so it actually does it for the directory you choose to do it. So when you actually fire up this FS Droid, it prompts you what directory you want to monitor.
Right.
And then if that malicious application is doing it as part of that directory, then yes, it will do it.
Oh, okay.
Yeah.
Got you. Cool.
Could one solution to the problem be that every time a mobile app writes to a data store, it encrypts, and every time it reads from that data store, it decrypts, so any malicious person wouldn't be able to make sense of it? Or is it just making life too complicated?
In which platform you are doing it, that's a good question, because in terms of iOS or an Android or for any mobile platform, it would be possible to get your encryption decryption string. So the current solution for which we give it to our customer is, what you do is and we are not saying you do not store the data. You have to store the data because that is what the business requirement is. Now, you do not store any private or a sensitive data like in credentials. And even if you want to do it, what you do is you store it encrypted. Do not perform any decryption on the client side. Take the encrypted data, send it to the server, because whenever there is a login, you need to validate with the server. So take the encrypted data, send it to the server, let the decryption happen on the server side, validate the authentication, and then come back. If you perform both encryption and decryption on the client side, that's when the problem starts. BlackBerry, yeah. Sorry? Yeah, so yeah, pretty much the behavior is almost same. In terms of Windows, I think although the stat says 2%, if I look at the review from the review perspective, I would say if we are doing like a 50-55 application review a month, we see like 1 or 2 applications, maybe 1 application which is a Windows application. But there has been effort onto the Windows mobile application development as well. So they're catching up. The other category is more like a smart TV application, let's say. Samsung Smart TV has an ability to write an application, your LG has the ability, Sony has the ability. Then there are like devices like Roku devices and Hulu devices and whatnot in US. All those will fall under the other categories. All right, thank you guys.
Go ahead and start streaming out. This class, or not this class, sorry, this presentation hopefully will give those of you who are just starting to get into mobile development and you're thinking, well, what do I need to worry about in terms of security? Hopefully this will put some things in perspective. Because it is a little bit frustrating. In fact, this presentation was born out of almost everything else in my life, extreme frustration, right? You go and you explain these things to various people day and day and day and day, over and over. And just like you guys know the security world, the development world, just the world in general, it tends to be these extremes, right? There's some people who say, oh, you know what, it's fine, we outsource it, we're just going to put it out there, it's good, right? There's that extreme. And there's like the other extreme that are like, oh, my online catalog, I went ahead and I put in anti-jailbreaking detection software and everything else. It's like overkill, right? It's like, you know, it's like the U.S. military. They got, you know, 10 times more military than anybody else, and they just keep throwing things at it. So you can find yourself on either one of these extremes. Do you guys agree with that or no? The only good thing about OWASP is there's no extremes here, right? It's all. So, oh yeah, microphone. Do I need a microphone? Can you guys hear me okay? Can't hear me. Okay. Great. All right. Can everybody hear me okay? So my name is Jerry Hoff. I'm an OWASP volunteer. I work at White Hat Security. I've worked at these various companies, White Hat, Morgan Stanley, AppSec, Lehman Brothers, and Washington University. So I've kind of had experience, at least dipped my toe into almost every type of person that comes to one of these events. Academia, professional developer, pen tester, code reviewer. I'm Morgan Stanley helping to set policy and look at applications, acted as a gatekeeper, and now I'm a vendor. So I got all those different badges. As for OWASP, probably my most well-known thing is the AppSec tutorial series. It's only 4 videos. They're 10 minutes long, but somehow they seem to be quite popular. Gotten about 250,000 views. The last couple years of my life have just been crazy, but now I'm trying to get back into making some of those. So I'm collaborating with the great Simon Bennett on the next one, will be coming out hopefully shortly. I put Tom and Jerry up here because people always take my first name and my last name, Jerry Hoff, and they kind of like merge it together. So they're like Jeff or something, right? It's like, but it's not, it's Jerry. Just think of like Tom and Jerry. Okay, so, oh yeah, one other thing I want to mention. This presentation was originally written for the OWASP Japan, right, which was earlier in the year. And I got most of it was originally in Japanese, and I got most of the Japanese out, but when the screenshots and stuff like that, they're still in Japanese, but that's not relevant. Don't say, is there a hidden meeting here, or is it like only Japanese Google does this? No, it's just completely circumstantial to the presentation. Okay, so speaking of my frustration, okay, this is what I've observed, and I checked with Google to see if there was some validity to this concern. A lot of my clients have now started to come to us and say, mobile, mobile. It's all about mobile. We need more mobile security. We're really, upset about the way our developers are developing mobile applications. And that's, you could say that that's valid. But I happen, especially with clients and with, other organizations I've done consulting with, I know that the server side is not up to par. It's not optimum. It's not anything that could be considered robust. But yet now there's all this focus on the device itself. Have you guys noticed stuff like this before, potentially? Everybody's worried about this device. Personally, I think there might be a psychological aspect to it. So for a non-developer, I think this thing is like crackling or something, but for the non-developer, it's hard to understand web servers and databases, and like the average executive just thinks that's all magic, right? But the phone is something they can hold in their hand. They take it with them to bed. They wake up in the morning with it. So it's something tangible. So then you start to focus as if this security on this phone, the points on this phone, somehow supersede that onto the server. That was my observation, anecdotal. But I checked on Google Trends, and you can clearly see that, again, this is not scientific, but web security, the number of searches are actually going down over time. But mobile security, you can see that comparatively, the searches for mobile security are much higher than web security. Is that justified? What do you guys think? Is it justified? Equal? Mostly BS. That's pretty much this talk, yeah. Yeah, so you've got one camp that says, yeah, the device is, the code that's running on the device is potentially introducing more risk to an organization. One camp would say, the server side and the mobile device, they're both adding the same amount of risk. And then there's some people who say, well, most of the risk is on the server side. So this code is, this presentation, I'm going to be going what my thoughts on this issue are. You are free to disagree. This is not like a lecture where I sit up here and talk. Disagree. You can make it as interactive as you want. Okay. So a lot of the talks that I give, other talks tend to be extremely high level or theoretical. I try to make mine very practical. And if you think that you've got a different experience or you want to offer something else, feel free to do so. Okay, so again, where's the risk? Why is this an important question? The reason why it's an important question is because this is what we were talking about before, the phone versus the web server, we only have so much time and money to spend on security. This is one of the fallacies that I think we tend to, as a community of security professionals, tend to devolve into. When I was a consultant, I used to say, we need to fix every vulnerability. It has to happen, right? Then I worked at a bank where they had 1,500 web applications and hundreds of thousands of known vulnerabilities, and then you start getting taken aback saying, okay, there's no way we can fix all this. At a certain point, you have to accept some amount of risk. Okay? As painful as that is for the people who charge by the hour to hear, you have to wind up accepting some risk. And that's just a state of life, right? We accept risk in all areas of our life. So where do we invest our time and money, and what proportion do we put on which side? So first of all, let's set the stage, not to be overly pedantic, but obviously when we're talking about mobile devices, we're talking about tablets, we're talking about phones, we're talking about watches, we're talking about things that are designed to go into mobile devices and normally be carried around with individuals on a daily basis. So that includes all that you see above here. Anybody have a Windows phone? What do you think? Fantastic. Fantastic, yeah. Oh, you got the T-shirt. Wait, you guys work at Microsoft?
No, but we will be talking about them tomorrow.
Oh, okay, good. Yeah, I mean, it's kind of interesting. Microsoft is in a position, potentially, since they don't already have a huge consumer base, right? So if they went for, it's very hard to sell security to consumers, one could argue, right? But if you start going after more business-oriented, then security all of a sudden may become more of a higher selling feature. So they're kind of in a pole position to potentially pull something like that off and build a more secure environment to run applications. Again, that's all just speculation, but interesting. Anybody still use BlackBerry, or are they just completely one holdout? Yeah. How does that feel when you go to the BlackBerry App Store and there's 2 things in there? Playing Snake? No, joking. They're gonna come back. They're gonna come back. Yeah. They're gonna come back. Okay, so you guys know the basics. Again, I have to state this because you would think that everybody knows these things, but very frequently people sit in these presentations and they're not quite sure. There are multiple ways to build web applications. Okay, some people, even I hear professional developers go, oh yeah, I know, it's Objective-C. Or, yeah, I know, it's this or it's that. But there's actually several different ways that you can build mobile applications. So what are they? What are some ways that you can build mobile applications that you can then submit to an app store?
You can do mobile web apps with HTML5 containers.
Yep, so you can use just plain HTML5. You can pull out a web container, stick the whole thing in there, absolutely. And what else? You can use PhoneGap, which is we're going to talk about that in a second. It's kind of a hybrid where you basically have JavaScript API wrappers over the API of the phone. You invoke it using JavaScript. Does that sound safe to everybody, invoking native phone APIs with JavaScript?
Awesome.
Yeah, I love it, right? Gets me some warm and fuzzies. Okay. And then obviously you've got languages such as Objective-C, Java. In Android devices, what languages can you use? Right, and then you can actually circumvent the JVM by using C++. So there's an SDK for C++ with Android as well. For iOS, what languages are at your disposal? Objective-C, this is why we have to go over these, and what? Swift. Swift is a brand new language that was just introduced by Apple, a few weeks ago? I'm already seeing ads like on job sites saying, searching for Swift developers must have 3 years experience, right? Have you guys seen that stuff? I don't know. Okay. So yeah, you guys got them all. So those are the different ways you can build. You obviously have thick clients. What would be one thing to take in mind if you're looking at thick client versus web? I mean, what would be like a few of the risks that would jump out at you immediately that would be present in one and not the other?
Repeat that question.
Yeah, let me back up. Actually, we're going to get to it in a second. But the question simply is, if you use thick client controls as opposed to web controls, does that make a difference in the security model? XSS, absolutely, right? So, I mean, that's the big one that would jump out. If you're not using HTML and you're not using JavaScript, the likelihood of XSS popping is probably diminished. Okay, so then we're going through these different technologies, and then we have Firefox phone. Anybody have one of these? Not yet, not yet. I was in the subway in Germany a couple months ago, and they had like advertisements, in there, which kind of confused me because the Firefox team has told me before that it's mainly for like third world and stuff like that. So I wasn't sure what was going on. But yeah, Firefox is coming out, and what's their development platform going to be? Would you expect from one of the world's most popular web companies? HTML5 and JavaScript, right? HTML5 and JavaScript. We see kind of a theme here, HTML5 and JavaScript. Okay. There's always people in the audience that are developers that are like, well, I love JavaScript. Would you stop bashing it? We're not bashing it, right? But we are talking about the fact, that there are some security measures that we need to keep in mind when we are using these various technologies. Okay, so PhoneGap had been brought up. And again, PhoneGap is definitely, they bill themselves as building native mobile applications using HTML, CSS, and JavaScript, right? So sounds great. They actually recommend some very interesting things on their website. So one of the things, not to jump ahead on my own slides, but there was one thing that I read which was very interesting. In the questions and answers section, people said, hey, well, I'm concerned writing my applications in JavaScript because anybody can go to the App Store, take it, decompile it, and see my JavaScript. Right? What are we going to do? Well, first of all, it's not exactly like unique to this environment, but their official response was, hey, no problem. Just when the application starts up, go ahead and dynamically download your JavaScript and then run it that way, right? Anything that could go wrong in that scenario, you start up a phone that has basically a JavaScript wrapper that you can invoke native phone APIs, and they tell you to go out to the web, grab some JavaScript, pull it down, and then execute it on the phone. Well, cross-site scripting all of a sudden has a totally different meaning in this context. And if you're going over a non-HTTPS connection, anybody might be able to intercept and modify that code that's coming down to your phone. Obviously, that could lead to some very traumatic results. So just one of the various things. By the way, app stores come up. This is also a source of confusion for a lot of C-level folks and normal consumers. They say, well, I got it in the App Store. It's got to be safe, right? So what are the security checks that are being done, for example, in the Android App Store? There we go. Yeah, is there any? I don't believe so, right? I think there might be some cursory static code analysis checks, but clearly there is malware that is rife in these various app stores. What about Apple? The secret sauce, right? So you would think, but then of course there's been research that shows that you can get various code and so forth into these various applications. And just the fact that we talked about before with PhoneGap, if you're downloading code dynamically, JavaScript code, for example, from a remote server, pulling it down to a device and then running it, there is no opportunity for any app store, even if they were doing security checks, to catch something like that because the code is downloaded at runtime. So far, so good? You guys all feeling okay? You guys are looking a little bit depressed, right? This is getting a little bit depressing. Jim?
Why have there been so fewer problems in the iOS world compared to Android?
Oh, well, that's a good question. Yeah, probably scrutiny, right? So when you submit an application on Android, how long does it usually take to get up there?
Instant.
iOS?
Like weeks if you're lucky.
Does that mean that they're doing anything really differently? Not necessarily, right? Not necessarily. Yeah, that's a really good question. I don't have an easy answer for that one. But yeah, clearly with the Android store, there's like rife with malware and everything else. It seems to be less on the iOS store, unless we're all just living in a delusion and there's like malware everywhere and we just don't know about it. Yeah, that's a good question. Well, yeah, so then you might say, so once again, Apple maybe perhaps signed that particular certificate. Does that mean that you can't put malware there, malware in their store? No, but they can turn it off. Paco.
To be clear, the notion of the Apple App Store, you have something with the identity of the person who put the thing there.
Mm-hmm.
And the Google App Store, I mean, anybody can sign anything.
Right.
You really don't have a tight line.
Right. Right. Yeah, but the only counter to that, I mean, the only thing I would argue just simply is if I have a stolen credit card, I can make an Apple ID account, and then there's no traceability. I mean, there's no traceability to me, potentially.
If I'm going to download the Coca-Cola app,
Uh-huh.
I have some real high confidence that the one that's labeled Coca-Cola in the Apple App Store really genuinely came from Coca-Cola.
Yeah, very good point. Very good point. Yeah, so there's at least some semblance of repudiation or with authenticity of a particular application. Yeah, very good point. However, though, I mean, I guess the counterpoint might simply just be games and things like that. I mean, you just download any random app in the Android store. Like, have you guys ever gone to the Android store? You download some weird app, like, you know, whatever it happens to be, just some bizarre app, and they're like asking for like 50 different permissions. Like, hey, I'm going to access your phone, I'm going to access your pictures, I'm going to access this and that. And a lot of that is malware. So even with maybe potentially high target code that would be like Coca-Cola and stuff like that, there's still a bunch of weird malware. So yeah, it's kind of it's a strange world that we live in. Apple iTunes does search obviously for banned applications, for pirated applications, things like that. There are a few that make it through every once in a while. There was somebody who put a MAME emulator. You guys all familiar with MAME? Yeah, they put a MAME emulator inside of a game called Gridley, and then they put it into the App Store. And if you knew exactly where to put your ROMs, then you could essentially have MAME running on your unjailbroken iPhone. So it was kind of cool. Okay, so we've kind of gone through the basics. We've talked about what's all on the client side. You guys, hopefully, if you're here, should be very familiar with the server side, right? So what languages now exist on the server side, or what technologies do we use to build server-side applications? Everything, right? Java, .NET, PHP, Python, Ruby, Go. What's that? JavaScript, right? If you're using Node. Swift. I don't know if they have Swift on the server side yet. Yeah, but who knows? You never know, right? That could be a job description. And then, Perl potentially. So the main question then really is, is mobile secure? The word secure and the word risk are like some of the most misunderstood words that I hear here at OWASP, right? Even people who live and breathe this stuff, it's like, secure, risk, this, that. And we all kind of like look at a different piece of the puzzle. So I'm going to take this from the perspective of the developer, right? I'm writing an application. What are the things that I need to watch out for when I'm building my application? If you do cursory research, if you go to Google, you type in mobile security, what do you think one of the first links you're going to hit is going to be? It's probably going to be OWASP. And well, probably above that, you might have like the Apple Developer's Guide. You might have this. But yeah, so let's talk about OWASP. What is OWASP? What are its offerings to the world as far as mobile security? Mobile top 10.
Mobile top 10 for developers, mobile top 10 for assessors. There's the jailbreaking guide.
Mm-hmm.
There's lots of guides in a variety of different places.
Right.
In the mobile ecosystem.
Right. So let's stick with the first one. So like the mobile developers, the top 10 mobile guide, right?
That's from the European foundation called NISA.
Okay.
Who actually donated that to the OWASP Foundation.
So you know what usually makes me doubt lists? That all of these like major risks we're all supposed to watch out for, like coincidentally always come in 10, right? There's always these like 10, 10, 10, 10. Does that mean if you download this list, and again, there are people who base their entire security programs off of top 10 lists, which is not something I'm a big fan of. If you're a developer and you go download the mobile top 10, I mean, is it a good thing to follow all 10 of those rules? What do you guys think? Again, you are security fundamentalists, so keep that in mind. But what do you think? It's impossible to say without knowing the risk profile of the department, of the company, of everything else. What is their risk appetite, right? You might say, well, we want to code to make sure it's absolutely perfectly unhackable, it's completely safe, whatever. Is that possible? No, right? It's not possible. Even if it is possible, if you have to spend a ton of money and time and effort doing it when maybe the customer who ordered the application doesn't even have a really big security concern, you're wasting their money. You're wasting their time. You're wasting their competitive advantage. Conversely, sometimes you might be building an application and the top 10 is not sufficient, right? I used to do a lot of consulting for quasi-governmental agencies on the mobile side, and they had extreme restrictions on mobile applications, and therefore a top 10 list would not be sufficient. Sound reasonable to everybody? Sounds like it's common sense, but you would have no idea how many people are like, you've got to follow exactly these top 10, as if it's like some magic, scientifically crafted number of applications. It's not. It's a bunch of guys getting around saying, okay, just pull up some, what are these things? Or maybe there's some data to back it up, but a lot of it is, guesswork. Okay, so again, this is kind of the breakdown, web and mobile. Blah, blah, blah. Main points. So when it comes to getting started with mobile security, forget about top 10, forget about this and that. I hear people in the hallway saying, yeah, I just started a mobile application. The first thing I got to put in there is, anti-jailbreaking code or, this or that. Stop. Focus, first of all, in my opinion, on these three things. These are the three things that are most important for developers to really understand. And they're pretty straightforward. Insufficient transport layer protection. I think we all know what that is, but I'm going to get into it. Unsafe data storage on the device, right, which is probably one of the things that actually gets the most press when companies get this wrong. And then business logic on the device, right? So this is, pretty much the same subset of issues that also affect quite a bit of number of web applications. So first of all, insufficient transport layer protection. You guys know that most secure data should cross over the internet using what? HTTPS, right? TLS, hopefully, right? What about in the web? What about in the mobile world? Do you think that that's true? Do you think most of your secure data is going over secure connections? How do you guys know? Uh-huh.
That lets you really, really easily evaluate different mobile applications.
Mm-hmm.
It lets all your mobile apps go through a simple
Yep.
Wi-Fi connector, and some of the most, seemingly what should be the most secure apps
Yep.
have at least some level of plain text of sensitive data going through.
Oh, yeah.
This is getting better fast.
Mm-hmm.
A lot more eyeballs on it.
Mm-hmm.
But Jerry, especially if you go back like 2 years ago,
Mm-hmm.
like top tier, top 10 banks doing plain text with shared keys for first generation mobile apps. Those are ridiculous.
You always get these sprinkling in the news, like every couple weeks. It's like, this application was sending my private data over an insecure connection, or this one was sending my private data over an unsecure connection. Is it really that hard to transport data over TLS? No, but it's just for some reason. So again, before you jump right to the anti-jailbreaking code and all these other kind of things that potentially in some environments would be helpful, why don't we get this straight, right, to begin with? You had mentioned Pineapple. Let me throw out another tool. How about Zap, right? So I use Zap regularly in order to inspect mobile applications. How would one do this? How does one use Zap with, for example, taking a look at the data that's leaving an iPhone application? A proxy, right? So you just make sure you're on the same network. There are proxy settings within, for example, iOS and Android, where you can say, hey, use this as my web proxy. You can run Zap at a particular port, and now you can see all the data that's leaving or entering over HTTP or HTTPS your device. Has anybody ever done this before? What? Just 2 people? 3? Okay, okay, good. You're like, yeah, I thought about it once, right? So, yeah, it's extremely enlightening when you start to see all the data and all the requests that these applications are making. You see all the way they're spying on you. You can see the third parties that are being invoked. You can see the advertisements. You can see all this kind of stuff. I'm sorry? Sometimes it's best not to know. It's just best not to know, right? Oh, yeah.
Well, it's not just
oh, I know.
it's telecom. Let's just add a couple headers here for fun. It's out of control.
Let's add some JavaScript so we can track various users, and this is not right, yeah. Okay, so yeah, this is a fun exercise. If you guys haven't done this before, I directly recommend, since only a handful of people apparently have done this. I mean, for me, it's like, how could you not do this, right? I mean, you got this device that contains all your most sensitive data. Don't you want to see what it's sending back and forth? Maybe you are right. Sometimes it's better not to know, but I think some people just like to know. So, interestingly enough, certain applications will reject. Now, if you go through a proxy, what should happen with an HTTPS connection? What would happen in a browser? Yeah, it says warning, right? The following connection cannot be, insured. Click more data. The certificate is not valid, etc. What should happen on the mobile device? Same basic thing, right? Allow you to click through, or maybe even block, right? So what do you think? Does that actually happen? It depends on the application, right? In the case of iOS, they'll actually pop up a message saying, hey, warning, the certificate's not valid, right? Which could put your confidential information at risk. There's not even an OK or cancel. It's pretty much OK, right? And it goes through.
The experience of Chrome on any device is much more dramatic when it comes to this. Chrome implements certificate painting, so they have much richer ecosystem of certificate-based error messages.
Right.
Way more than the absolute pollution junk that is Safari.
Well, but remember, though, this is not Safari. This is not Safari. This is a thick client application. Yeah, sorry about that. I should have mentioned that. These are thick client applications. They might use web components underneath, right? Like, I believe, actually, to be honest, I believe this particular one uses, whatever. So, these are thick client applications, but in this case, it says this. In this case, they actually just bomb you out. They say, hey, I can't make a secure connection. So when we talk about, transporting data over a secure connection, remember, if you're not using a browser, you can't depend on those Chrome error messages and things like that popping up. Your code has to be able to handle these various situations. Sound reasonable? Has anybody ever put stuff like this in their code? Like basically, if you can't have a secure HTTPS connection, you bomb them out? Oh, good. Hey, I love you guys. Yeah, that's good. Good. It might, to be honest, though, it might not be necessary. It might not, right? Let's say this is just like, just a catalog where you're just reading, some basic data. Depending on the application, you could actually argue that it's not pertinent or it is, right? However, if these guys use any web technologies, I would argue that everything should go over HTTPS because of the fact that JavaScript can be injected and it's being injected potentially into a device where the harm can be much greater than in normal situations. Okay, what is this again? Oh yeah, PayPal. This was an interesting CVE. Did anybody read this one? PayPal remote code execution. Essentially, they were grabbing JavaScript libraries over a non-HTTPS connection. I don't know. I mean, is that really worth its own CVE? I mean, it's like everybody in the world does this, right? So I'm not quite sure why they got their own CVE for that. But it was inside the PayPal application, so maybe the severity of the application was part of that reason. Okay, so this is the code, and this is all going to be publicly available, but these are the types of code that you want to have in there in order to do these types of checks and so forth when it comes to verifying that you have an uninterrupted HTTPS connection. Phone gap, this is that little blurb I told you guys about earlier. Reverse engineering is a concern of many people that use phone gap, since one can simply open the application binary and look at the JavaScript source of an application, which you absolutely can't do in any other technology, right? I mean, that's, what? Okay. So it just says basically it's easier to decompile than Java or Objective-C. Yeah, I mean, JAD is so difficult, right? We can figure it out. PhoneGap can get around this since the developers can download JavaScript in their application at runtime. Again, that's sometimes even following like the advice that's on the mobile technology platforms are not perfectly designed for security. So again, make sure that you look at these things from a skeptical perspective.
There's a lot of controversy around the OWASP Mobile A10, which is binary protection. There's some who thinks it's really important, other who thinks it's complete utter snake oil. So this is a very
Well, so it's an interesting thing that you'd bring up then about that one particular, Jim. You could actually argue, depending on the application, right, that, again, this is, I guess, the main thing in the security world that we all, this thing that we all seem to fall into. People seem to either be on one side, like, yeah, it's absolute snake oil, or on the other side, which is you absolutely have to have it in every time. But there's no other field that's really like that, right? Everything is situational. Everything is gradient. Everything is based on risk. One of the things lately that I've also been talking a lot about is risk-based approach. Has anybody in here heard of risk-based approach? It's essentially when you have a whole bunch of vulnerabilities, right? A severe in one application is not equivalent to the severe in another application because the applications themselves are of different values. Does that make sense? So being able to actually take every vulnerability and reduce it down to a common score, which we do usually in dollars and cents, or euros and cents, or pounds and cents, put into a tangible score so that way stakeholders and security engineers can be speaking the same language. And the same thing goes with like security controls. There's always gradients. Okay, unsafe data storage on the device. Unsafe data storage on the device. This is the one thing that gets a lot of people. There are so many different ways to store data on a particular device, right? So a lot of the times, you know that you have SQLite databases that you can access. When you open up a browser, it's got SQLite databases. Depending on the device, you might have an SD card. You might have memory. You might have file system where you can store particular files. You might have various calls within the device itself where you can store data in keychains and so forth. So data can actually be polluted all over a particular device, right? What's the main rule about storing data on a device, do you think? Don't do it, right? Again, situational, right? Definitely situational. Sometimes you can't help it. Like a phone application, a camera application has to store data on the device, right? You can't, I guess you could maybe upload every single picture to the cloud, but that's not really realistic.
I hate to use this term, but for enterprise software, for banking software, for software that has a really strict risk model, you don't store data on the device. It is that simple for that classification of security.
But we have to define what data we're talking about, right? So like a first name, right? Or maybe a preference of like, do you want to receive ads or not? That might be one classification. A password might be something totally different. But I think the thing to keep in mind is mobile devices have a higher frequency of being lost than probably your average computer. Would you guys agree with that or not? So there's a slightly larger risk in this data getting lost, which is why storing sensitive data on the device is not right. But if you look at the number of laptops that are actually lost in a given year, I think it was something like 400,000 in airports alone every single year that are left behind. And those definitely have sensitive data. So it's kind of a murky issue. You will hear fundamentalists on each side. You will hear people who feel very, very strongly. But at the end of the day, it all depends on the risk tolerance of your organization. But yeah, I would agree. The rule of thumb is don't store sensitive data on this device permanently. And here's why. Has anybody whipped out a tool called iFunbox? Okay, this is your homework assignment for those of you who haven't, right? Pull out iPhoneBox against a non-jailbroken device, plug it in, and take a look at, throughout the different file systems, all the different files their applications are storing. It's sometimes very enlightening as to what's actually being written by these applications out onto the file system. All right, as far as iPhone storage, again, these are just simply code showing where various text and strings can be stored. You've got, for example, the iPhone file store. You've got the iOS user defaults data store and the iOS keychain. These are just using iOS as an example of all the different places. If you're doing, for example, an assessment on an application, be aware that these are all places the data can lurk. And then plist. And then logs, right? Okay.
How about when you're in iOS and you flip to an application, you get that screen back really quickly. Because they're taking a screenshot of your application, you background it.
Yep.
So imagine like being in an app with sensitive data and you background it.
Yep.
You just dump that to a plain text file.
Yeah, no, I would agree. But
so out of control how many places you can leak to your point.
Oh, I totally agree. I totally agree. That one particular case in point, though, again, just to make sure everybody heard what Jim said, when you switch tasks in a mobile phone, it actually takes a screenshot of whatever you're on. And you guys have seen this before, right? Like you're going from like one tab to another, and you can see it's like outdated. Then you bring it to the forefront, the application runs, and then the screen is updated. It used to be that those particular screenshots could get written to the disk, and therefore if you lost your phone, somebody found it, if you just happened to be like on a screen that was showing sensitive data like your bank balance, right, when you switch tasks, then that would leak out, right? I would agree. However, again, think about the data that we're talking about. If it's a banking application, if it's a government application, then that might be a valid concern that we need to fight against. But yeah, to Jim's point, data just leaks out everywhere. However, Apple has a solution for this, right? Which is, hey, store all sensitive data in our cloud, right? So they basically say you can store your passwords in our cloud, your contacts, your calendars, your reminders. It's almost like you might have already given up, right? You're like, well, all my stuff is already in Google. Might as well give it to Apple as well. I'm like, who cares at this point, right? But nevertheless, it's not something that I feel securely doing. But it is something that instead of storing it on the device, developers have at their disposal. Okay, last little point here. And by the way, does anybody have I should check the time. 15. Oh, crap. Okay. I think I'm on slide 20 of like 76 or something, but we'll go through quickly. So business logic on the phone and direct object references. This is a biggie. This is what we find all the time. First of all, is it hard to decompile mobile applications? No. No, it's extremely easy, right? When it comes to iOS, there's a little bit more work than when it comes to Android. Android, for example, just to use that as an example, you download the dex file. You essentially can make a jar file out of it by, I think, renaming it, right? And then it's done. And then you can run it through, or you can run it through dex to jar, to get to the jar file. And then from the jar file, you can decompile it using JAD. Whole process takes, what, 30 seconds, right? And then you can see basically, just like this in plain text, pretty much all the Java that goes into these particular applications. Has anybody ever done this before? This is a fun thing to do on the weekends. I don't know about your weekends, okay? But this is what I find to be very fun. So you can find in like the credit card processing information. You can find sometimes you can find all sorts of like crazy comments even, crazy method names. I found very offensive stuff and some very well-known like top 50 mobile applications that would just mortify them if that ever came out. Fortunately, journalists don't have a tendency to start looking through, jar files. But nevertheless, you can find all sorts of really interesting goodies just by doing this very simple process. So the idea that somehow, the reason why I'm telling you this, you're like, I already know this. But the reason why I'm mentioning this is because developers, when they're coding, tend to put the blinders on and think somehow that code is not going to be looked at, that code can't be tampered with. We already know the connection can be tampered with. The code obviously is right there. This is also what causes the issues on the Android store, where people take the code, they just simply recompile it, they upload it, they put some changes in it, and now you've got a lot of pollution in the App Store. Okay. And then, of course, direct object references. Hopefully everybody is familiar with what this term means. I hate to ask these questions because nobody will say, like, I don't know what it is. It's all it is access control. It's when you take some value from the client, from an untrusted client, that you use on the server side, potentially, to make some kind of access control decision exclusively. This is a piece of cake. Like I said before, when you put up Zap and so forth, you can do direct object reference all day, right? You can look at all the code that's running on the client side. You can see the messages it's sending back to the server. You can make modifications to these particular files. You can win in games all day, right? Has anybody ever done this, cheated in a mobile game just by changing the data that's being passed and forth? No, Jerry, no. No, never. Never. Yeah, all right. Anyway, just as a trivia question, what game is this from? Anybody know? You guys are disappointing me. No. That's the original Nintendo Wrestling, right? That was from very disappointed, you guys. All right. So one of the areas we find this a lot, for example, in the P list. Have you guys ever, this is like actual code that we've seen, like is paid. You can change it from false to true or just change that value. The application now behaves extremely differently. We see this just all over the place. Developers, especially when they're getting in the mindset of building mobile applications, they feel like they're building thick client or server applications. They have direct object references. But again, that's untrusted area. You can't trust that data that's on the client. Okay, so hopefully, we've gone through these three things that are kind of prevalent. There's many more things that could potentially happen, but for your developer just starting out, those three things will pretty much get you through, some base level of security. Can you say the same thing about the web side? No, there's a lot more things that can actually go wrong. So just to very quickly enumerate them, injection attacks. So you've got SQL injection. That is something that is much more likely to happen on the server side than on the client side. Would you guys agree with that? No? Uh-huh. Attack code over to the server? But where does the SQL injection happen in this scenario? No. Where does the SQL injection happen? It doesn't happen in the proxy. It happens on the server, right? So that's what I'm saying. You're agreeing with me. It's more likely to, right? It happens on the server, right? It doesn't happen on the client. It might originate on the client, but to be honest, that's not the client's fault. That's the database code is screwed up, right? So, I mean, it doesn't matter what you send from the client. You have to assume all that data is going to be untrusted. It's the vulnerabilities on the server side. Right? This is the main point. I'm glad you brought this up. The main point is when you're starting to look at, a mobile application consists of code that's running on a device and it's running on a server. The code on the server side can screw you up a lot harder than the code on the client side. But yet people seem to be putting all their attention onto the client side as opposed to the server side. Okay. Must have been mobile developers. They're like, no, I don't want to hear about that, right? All right. Okay, so again, you guys get all the picture on how everybody knows how SQL injection works, hopefully. And even if you don't, I don't have enough time to explain it. Broken authentication and session management. Is this something that we have to worry about on the client side or the server side? On the server, right? Yeah, you might have controls for authentication and access, authentication and session management on the client. It might pass credentials. It even might do something dumb like, store a remember me cookie on the device, right? But that's actually small potatoes compared to other things that can happen on the server side. Now, the caveat to that, by the way, is don't store passwords on that device. It should go without saying, but of course, this happened earlier this year, right? January 16th. Unfortunately, a very slow news week for the media, and it came out, some security researcher came out and said, hey, I found unencrypted passwords stored in plain text on Starbucks app. Who cares, right? I mean, we find this like 50 times a day, right, in various applications. But this, for some reason, caught fire. Everybody's like, people are going to be drinking our lattes, and it's horrible, and our passwords are all out and everything. But what is the maximum damage that this could have done? If you lost, think about the threat model. You lose your phone, somebody finds it, they hook it up to iPhoneBoxy, they dig around in the file system, they find your unencrypted password, they can access your Starbucks account. Yeah, they got everything else, right? Like, oh, well, they got my email, they got my mail, they got everything but my Starbucks, right?
Now they're drinking Starbucks coffee. They get what they deserve.
Yeah, right, yeah. The universal karma. Right. But I had to point this out because I don't know if you guys remember, this was just earlier this year. This did not leave the national headlines for like 3 days. Like you kept going back to CNN or whatever you read, and like BBC, and it's like Starbucks. How could they have done this, right? And again, it's not a huge deal, but they were storing sensitive data, obviously passwords on the device. It's semi-related authentication, so I put it in here. Okay, and then finally, cross-site scripting. Cross-site scripting is everybody at OWASP's favorite topic, right? It's that perennial cockroach that never seems to go away. It's just, that's the way it is. Is it as significant in web applications as it is in mobile applications? I would argue it's probably a lot harder to get cross-site scripting to pop on a mobile device than on a normal web application. That said, if you are using something like PhoneGap, right, there is the potential for being disastrous if you could actually get it to pop. But for the most part, just for the fact that you've got this wide variety and collection of languages, for the average developer, this is not something that is potentially going to make or break the security in your particular application. All right, let me just get through all this dumb animation stuff. By the way, this is all from my tutorial series, so this is like from the from that YouTube stuff I was talking about. Okay, now more of this. What is this one? Insecure direct object reference. Again, we already talked about this. Any type of value on the phone can be modified. Somebody using a proxy, send back to the server. You cannot trust the data that's coming in from the client side, even if it is a mobile application. I think developers are finally starting to realize this with web applications, but it seems to be rife in mobile applications. Okay, and then finally, one last thing, I believe, security misconfiguration. This is an issue that happens on both sides. Okay, misconfiguring the security settings on your application, that's something that both on the client side and the server side can affect them, I would say, to much more disastrous results on the server side. All right, since we're running out of time, I'm just going to skip. And then finally, if you kind of look down the issues as opposed to like out of the OWASP top 10, what can go really wrong on the client, what can go really wrong on the server, the way that I tallied it, the server deserves a lot more attention. So if we go back to our original hypothesis of where should you put your time and your money and more resources, hopefully you guys see it. I'm sorry, but we're still not out of the woods yet. You know, you can't just jump to the fun stuff and start doing mobile security unless you have a secure server on the back end. Okay. One last thing for more resources, even though I kind of bashed it through this talk, there's the mobile top 10. Not really bashed it, but you know, just basically letting you know you don't have to follow each and every one of these things. There's the iOS developer cheat sheet. Jim Manico is the product manager of the cheat sheet series. Phenomenal resource, worldwide renowned. There is an iOS developer cheat sheet, mobile jailbreaking cheat sheet, and of course you can also go to Google itself. There's an Android secure development documentation, and the same thing with Apple. That's it. That's it, guys. How much time do we have for questions?
Got 5 minutes.
All right. If you guys want to ask any questions, feel free.
Stick your hand up and I'll bring the microphone over this way.
Sure, do your thing. No questions? All right. I love you all. Thank you. Have a good one.
the headline news. And here's our comedians for the day. All right.
Yeah, it's all right.
They warned me that you're going to have to speak into the mic in order to get it on the recording. So we'll do that. And I'll also set this up, because last time we really got Chris and Josh egging each other on last time we did this.
Did you record it last time?
Yes, I did, and it's been live ever since. There we go.
The big thing on the stand in front of you is a clue. I don't recall the stand.
All right. So welcome. I am Mark Miller, and that's me up there in one of those pictures up there. I'm from New York City. How many people have heard of New York City? Okay, good, thanks. We're going to go quick because we got a lot of things to get through, but I want to introduce everybody. Chris, say hi.
Hi.
Where are you from, Chris?
VP of Research at Veracode from Boston.
From Boston, good. Matt?
Matt Tesoro, I work for the product security. I work for the product security group. On the button.
Yeah.
I work for the product security group at Rackspace, and I know to use microphones. And I'm from Texas.
Josh Corman, and CTO for Sonatype, and do things like rugged software, and I am the cavalry.
All right, good. Let's just move pretty quick. The online resources that I use, everything that you're going to see today was within the last 27 days. And there's a ton of stuff. And these are the resources that I used. These guys have been studying so hard, haven't you, Matt? So here's the rules of the game. The first one is when one of these guys gets a correct answer, they get 3 points. If they miss it, we subtract 2 points from their total. If they pass on a question, this is a new one. If you pass on it, you lose 1 point. All right? If a question is answered incorrectly, the second response, say if Chris misses it and Josh gets it, Josh gets a point for it because he's filtered some of the stuff from me. A correct answer from an audience member, if it goes to the audience, you can allocate your 2 points to any one of these guys. All right. So the moderator may arbitrarily give or take away points at any time. And Josh knows that's true. All right. I need a volunteer. Who would like to be the scorekeeper? Get out, quick. Who's got a paper and pencil? Or who's got a computer in front of them open?
Who can count? Who has fingers?
Oh, come on.
I'll do it.
Thank you. Jerry's got it. You going to stay for the whole session? Yeah. All right. Good. All right. Here's the audience participation. You're going to be part of the game to start. There's 3 questions up here. Just shout out an answer when you know. Okay? Name 2 out of 7 podcast series dedicated to security. Any 2. Good. Good. It all works. Good. That's good. What popular software security company came out with the campaign, Put a Monster in Your Corner, last week? You want to take that one, Chris? Veracode. That was a joke. I thought you'd like that one. What movie is reportedly going to get rebooted by the Iron Man 3 director Shane Black? Josh? Golly, this is going to be a tough day, guys. Look. You know this guy? Yeah. All right. Here we go. So that's how the game's played. These guys are going to get first shot at it. Chris, you want the first question?
Sure.
So, hacks in the news. First of all, how were 2 9th graders able to gain full access to system credentials on their local ATM?
They got the manual.
They got the manual. Give this guy 3 points.
Bank of Montreal.
Do you know that
Winnipeg.
story? Yes, this is points.
3
3
points
points
for
for
me.
Chris. That's an awesome story if you haven't read it yet. When I get you the deck, I've got the full news story inside the notes view so you can actually read the news story. But these guys read a manual online at lunch and went over to their local ATM and tested it out. Oh, this is cool. And it, full access. Matt.
Yes.
Name 2 out of 5 hardware companies that had confirmed cross-site scripting and vulnerabilities within the past month.
Oh, month?
Hardware companies.
Wow. Now I get to debate what's better to just blindly guess or
If you pass, you only lose 1 point. If you blindly guess, you lose 2.
Well, I'm just going to go for broke and pity from the audience.
Okay.
Let's just say...
You want to use a lifeline?
I can use a lifeline, yeah. Do I get lifelines? 'Cause
Sure.
I have no freaking clue.
Somebody help him out. There you go, Matt.
Yeah, I'm gonna blow the inflatable thing and float across the ocean and pass.
All right. There you go.
Oh, interesting.
These guys. Every one of these guys.
Let me guess, it was in their web front ends. They were written by interns.
I think they're all hosted at Rackspace.
Hey, we just provide the bits. If you have bad bits in us, it's on you, right?
Okay, Josh, you got the mic. The largest denial of service attack in history hit what site in Hong Kong last week?
It was the elections.
The elections, yes. Give the man 3 points. That's pretty bad, right? Whew. All right. Chris, a flaw has been discovered in the motherboards manufactured by the server manufacturer Supermicro. What was the flaw?
You could get the administrator password by making
3
a simple
points. This
web
guy's
request.
been studying. Wow. 32,000 servers openly broadcasting.
I read it, but I didn't remember it. I slept for 4 hours last night.
You know what?
I was in the bar at the hotel at 5 this morning.
Give Matt 2 points. Give Matt 2 points for that.
I can vouch for that.
Yeah.
Matt gets 2 points for being in a bar last night, past midnight.
And a
All
couple pubs before that, right?
Matt, Columbia University researchers developed a tool called PlayDrone that indexed and analyzed what?
Oh, I'm going to guess because I have no clue.
Yeah.
I think that was that the one that was flying around and, it wasn't doing like a war driving, but with the drone, or am I incorrect on that?
That was a cool one, but it's incorrect. Yeah.
Hey, at least I got a cool bad answer.
Anybody know that one? Go ahead, Chris. Chris got it.
The Google Play Store was looking for hard-coded credentials.
Yes. Inside the applications themselves, hard-coded the credentials. Good. 1 point for Chris on that one. There we go. Okay, these are for experts only. This ups the level a little bit.
I never got my last question.
I'm going to give you one right now. Millions of LinkedIn users were at risk with what common attack method 2 weeks ago? Using LinkedIn. That's basically the answer, but go ahead.
Is it the Matt DeCero, a.k.a. Man in the Middle?
Yes.
Do I get style points for that?
You know what? Give Josh
I'm the
4
Matt
points
in
for
the middle.
styling that one properly.
Oh, man.
There you go.
Pandering.
Chris, a recently discovered Trojan, and that doesn't mean a condom, a recently discovered Trojan app encrypts files, what type of devices, and asks for ransom, right?
I actually don't know, but how else could it be anything but Android?
You got it.
Dang
3.
it. That was for experts. That was a softball.
You know what? Take 1 point away from me.
If you can't win, take down your opponent.
Okay, Matt, a new powerful banking malware called, I don't even know how to pronounce it, Deriza has emerged. What type of attack does it use?
Oh, man in browser.
Man in the browser.
No? Yes? I have no idea.
Man in the middle attack.
In the middle. Does that work? That's like those browser objects, right? You get -3.
What do you think? I think he gets a -2.
-5.
Yeah.
In Texas, we use the word browser for middle.
All right, give me 1 point for that one. Josh.
Good save. Good save, yeah.
Zeus has a competitor, Josh.
Oh, I know this too. Do I have like a Jeopardy town?
3 seconds. You want a lifeline to the audience? You get one.
Yeah, you know it?
Audience. Audience?
I'll pass.
It's going to pass. What's that? No. It is not. So,
It's a strange word.
yeah, it's pandemia. Minus, he passed. That's -1. He passed. Yes, okay. You guys enjoying the game? Is it okay?
What's the score essentially?
What's the score right now?
Well.
It's like an election, right? The first you lose the hill.
He's not writing anything down. He doesn't even have a pen.
Chris, loophole in what company's payment system allows anyone to double their money endlessly? And this is for real.
Would that be PayPal, except it wouldn't actually work in practice?
Yes, it would be PayPal. 3 points. So the score is 3-0 right now?
I'm trying to overflow the buffer in a negative fashion.
Okay, audience participation. I'm going to throw this out so you guys can relax a bit. First of all, Elon Musk did something unheard of in modern business a couple weeks ago. What was it?
Give up all his patents.
He gave up all his patents. Did you guys know that? Yes, if you're, yes.
So who do I get to give my points to?
Oh, who gets the points?
I'm going to give it to Matt because he's so far.
Matt gets 3 points for that one. Yes.
Plus the oh well.
Oh, yeah. Okay, never mind. I'll give it to Chris.
Okay, perfect.
Okay. I got this one just for this group because in the
shut
United
up.
States they wouldn't know this one. Who was found not guilty in the phone hacking scandal from News of the World? Who are you going to give your points to?
Chris again.
Chris? Oh, man. He wants to go with the winner. He's
not going to answer any of the questions. Yeah.
Yeah, that was pretty amazing. And then 4 of the FBI's top 10 cyber criminals are from what country?
This sounds easy.
Iceland. The Vatican, did you say? Give Owen 1 point for that one. Oh, you really don't know? Chinese. Get it. Good.
Yeah, that's what I would say.
Who are you giving your points to? Oh, who said China? I heard a Chinese. Oh, I'm sorry. I heard his voice first. Who are you going to give your points to? Matt. Who are you going to give your points to? Matt. Matt is now in the lead. Yeah, 6 points to Matt.
You know.
All right. Okay, new section for the guys up here. Really? That's unbelievable. But you're going to have to believe it because everything up here is true. Scarily true. Who am I with? Chris?
It's on
Matt.
me now.
All right, you ready? A new phishing campaign says it has a tool to remove what vulnerability from your desktop computer? Hold on.
Dang it. I read that one, but the 4 hours of sleep just aren't doing me good. It was LinkedIn.
You about to time out?
I have no idea.
You're going to pass?
I'll pass.
Okay. Audience? Good. Who are you going to give your points to?
I've got the sympathy vote like nobody's business. I love it.
All right. Josh, why did Germany recently drop prosecution of the NSA?
I didn't know they did drop prosecution of the NSA. Because they're doing the same exact thing.
You know what? Give him 5 points for that answer. Really, they did because the prosecution says there's no evidence. I'm serious. That's a headline.
I like Josh's answer.
All right, Chris. According to the researcher Robert Graham, of 600 servers scanned, how many are still vulnerable to Heartbleed?
Say about half?
Exactly half. 3 points for this man.
Guessing.
I mean, half.
All right. Good. That was a quick.
But of course.
All right.
Oh, the business.
How many of these you guys getting? You getting most of them? I'm not seeing a lot. Colin, we should make a card deck out of this.
Every 2 weeks, yeah.
You say that in jest. I'm actually considering doing this online every 2 weeks or a month and putting it up and let people flip through. Would you read it? Would you read something like this?
Yeah.
Cool. I mean, if you could answer it and get a score back, would you pay to read it? All right.
Don't mess with the incentive structure because someone will pay to own it, right?
Now, this has to do with the Texas restaurant, so I'm giving you this one, Matt. Oh. What restaurant chain has had a credit card breach since September 2013?
I know Dave and Buster's did, but I don't think that was one of them. I know in Texas they got pwned pretty bad. It was,
I don't even know if you guys have this kind of food in Texas.
So it's not a steak place.
It's not a steak, and it's not Tex-Mex.
And it's not Tex-Mex. And it's not Mexican food.
All right. It's not Cracker Barrel.
Not Cracker Barrel. Vegetarian, there's actually some of those. We have Austin, right? The exception to the rule.
You know that Matt has not answered a single question this entire session?
No.
And he's leading the game.
But I felt really good about it. That's what's important. I'm from America.
2 points to Josh.
Can I see your watch so I can tell you the time?
I'm guessing here, but is it P.F. Chang's?
You're not guessing.
Oh, it is P.F. Chang's.
It is P.F. Chang's.
We do have those in
And that was by the sleuth, Brian Krebs.
Do you guys get that story here?
That was right, yeah. The Krebs.
Go ahead. You want to
Yeah, I mean, what I love about this story is, in response to the breach, they've gone back to sliding the credit cards instead of electronic.
Yeah, carbon paper.
Which is actually somewhat of a rational choice. Like, until they get confidence in the new system.
Yeah, I was surprised. I hadn't seen one of those.
I was going to say, yeah, the
It
bus boys
requires
are
a
out in the
physical
back.
attack, right? So I'm not saying that's a secure fallback, but I understand the instinct.
Yeah.
Okay. Chris, what's Snowden's former employer developing right now to help the government keep track of you? Well, actually, me. Seriously, me.
To keep track of you?
Yes, and I'm serious.
I'm very confused.
Give him 3 points.
I can't beat that.
Does anybody know?
I'm gonna pass.
You know what this is? It's a Fitbit. They're actually building an app for the government for fitness. They do Fitbit.
Really? But Fitbit doesn't have GPS, does it? I mean,
Some of them do, yes.
Oh, some of the fancier ones?
Location-based, yeah.
Special ones.
The special ones. I got a crappy one with no GPS.
We must track all yuppies. Terrorists could be wearing Fitbit.
Did you just call me a yuppie?
How many points
I mean,
did he
I'm
lose?
slow, but I'm... All right. Matt, how's this one for you? What company was recently put out of business after a major hack of their AWS account?
Oh, that was that Code.
It's got the word code in it.
Code. It was a GitHub competitor. Code Source? Code Space. Thank you.
Josh, who are you going to give your points to, Josh?
We'll split them.
All right, 2 points each for those.
Yeah, as a Rackspace employee, that made the rounds. Go.
Did you know that Rackspace is one of the few companies in the United States that has a giant tube that they can slide down to go from floor to floor?
Yes,
have you done the tube slide?
Yeah, oh yeah, many times.
They have actually races there in the office so you can go fastest.
Yes,
Just a little point.
Did anyone lose their source code? They lost people's source code. Anybody lose in this room? Anybody using that service?
Yeah, they really do lose the whole thing.
It's gone.
It's gone. Hackers got in there. They wanted to have ransom. They said no, so they went and hit the button.
What surprised me too is they were like, "What do you do?" Well, just like this magic thing of 2 accounts, right? Can't you like move data from 1 to 2?
Well, the interesting thing for me is they put their backups on the same server where they had the original data.
That was. Yeah, that's my thing. It's like if it's like it's like, well, you write it to multiple disks and multiple locations, right? Like it's the same thing for a cloud, right? It's multiple disks. They're just owned by different accounts or even providers, right?
They weren't even using 2-factor, right? I mean, that was the dumbest.
Yeah, you want to say that? Get it on the mic too, because they're gonna. Yeah.
No, they weren't even using 2-factor for their AWS login. Like they're running a company on this and single factor. Ridiculous.
Well, didn't PayPal get busted even though they were running 2-factor?
Well, yeah. I mean, PayPal. There was a PayPal vulnerability.
We got to go
today,
to
I guess.
3-factor right away.
No, it was only. But it was only in certain parts, right? It was only. I don't know.
All right. Who's got it? Josh? June 11th, Target shareholders decided to do what with 7 of 10 board members?
My non-answer is tar and feather. But I think the truth is renew.
Nothing. Absolutely nothing. Give him 3 points. There was up for vote on June 11th. 7 board members, people had put up to get kicked out, and the shareholders voted them back in just flat across the board.
We might actually get chip and pin out of this. We could actually come to this century in credit cards. So that would be nice.
Well, the other, I don't think this was the article, but also there was an article showing shareholders don't care about breaches. They said customers care about breaches, but shareholders do not care about breaches, which is kind of depressing.
Yeah.
It's kind of the opposite that it should be.
Yeah. All right. In a baffling move, TrueCrypt open source crypto project decided to what? Chris, you want to just give him the mic?
They decided to stop developing TrueCrypt.
There you go. They just stopped. And they haven't given a reason yet. Nobody knows why.
They'll like use this to decrypt it and go away. Also, they suggested they're going to use BitLocker. Yeah, go use BitLocker. Yeah.
Because Windows XP is out of maintenance. That was their main reason.
Public reason.
I think they just didn't like feature requests.
So Chris got 3 points on that one. You give him that? All right. You guys want to get together and talk? All right, reachers, who's got it? Matt? Yeah. Research, you don't have to crane around. I'll read it to you.
Yeah. I just like to know the pain that's coming.
Researchers found large global botnets and infected systems. What type of systems were they? And this is a powerful statement here.
This wasn't the home automation, was it? It was it was an embedded thing.
Anybody want to help Matt? What's that? Network drive. You just lost him a point.
NAS?
Anybody else want to?
Yeah. Hey, keep asking. Come on.
Point of sale systems, directly in the point of sale system.
Oh, really?
Yeah.
That one I didn't. I was all.
POS is very appropriate in this context.
That would be a double entendre.
You said June.
Oh, let me.
Not that I want to help Matt.
Okay. Josh, what accounts for 98%? What accounts for 98% of the worldwide Google Play revenue?
Oh, their revenue, advertisements.
Take 2 points away from him.
No.
Freemium apps. They put them in there, and then they put upsells inside the freemium apps.
Oh, the in-game
purchases. Yeah. 98%. And my daughter has about 50% of that. All right. Final round. This is the lightning round. We're going to pop as fast as you want. Catherine, how are you doing on these? Can I holler at you for some of these? Did you get any of these? Okay. Okay, you guys ready?
Never been more ready.
All right. You guys, anybody that answers first gets it. Feedly and Evernote went down from denial of service attacks. What did the attackers want?
All our bases?
2 points for that.
Yes. You get points for not answering.
Ransom.
Yeah.
But there's more coming. Keep an eye on that. Name 2 of 5 companies that were held for ransom recently with the attackers demanding Bitcoin. Probably the same 2. 2 of 5? Anybody want to take a shot? Vimeo? I mean, big ones. Big ones. Yeah. All right. Robert Scoble called it the stupidest, most addictive app I've ever seen in my life. And this is Robert Scoble, the guy that puts on Google glasses in the shower and takes
Flappy
pictures
Bird.
of himself. Flappy Bird.
Yes. Yes, my kids have it.
Anybody know what this is? Yo. Yo. Have you ever? Actually, people have found real uses for this. I'll leave it at that. I got the article on there for you to read. What's the most pirated show in history?
Game of Thrones.
Yeah.
Audience gets 3 points on that one. There we go. But which? Not which season. Which show? The red button flaw exposes major vulnerabilities in millions of what? You know, Red Button's a comedian in the United States. It's a Red Button plot. Really, you don't know this one? Surprising. Everybody's got it at home. Yes, good. Who do you want to give your points to? Matt.
I'll act the most happy.
Good. According to Network World, what is the next circle of hell for the security community?
Oh, like we need another.
I was going to say, any answer is correct at this point.
OWASP leaders list. Be nice.
Unpatchable systems. Yeah. All right. Within 10%, what percentage of security attacks are the result of human error?
50. As total ultimate root cause, 100%.
Give the man 3 points. 95%. Flat out human error. All right. According to the NSA, how loud was Edward Snowden's whistle? That's a trick question because he didn't have a whistle. According to the NSA, he never had a whistle. He didn't have anything at all that he sent to them.
Yes.
Is it?
We've just determined that zebras are white and black, not black and white. So this is good.
Have you ever seen Brian Williams rap? Okay. I was going to put that up here. What European country is used as the NSA's largest listening post? Whoa, who said that? 3. Germany. How many Germans we got in here? We got, holy crap.
The Germans.
And we're all listening.
Yeah, you with the headphones in the back. I get it.
It's turnaround fair trade.
But there's no evidence that the United States was spying on Germany.
We just tapped all their phone lines for fun.
What were 5 security apps recently? Why were they booted from the Google Play and Amazon store? This is sick. This is
the ones that did nothing.
good. 3 points for Matt. Security apps, you pay $3 for a security app, and all it says is when you punch the button, it says you're secure.
Wait.
Just like AV.
That's $47 less than desktop AV.
Okay, 3 points for Josh. Josh gets 300. All right. These guys made tens of thousands of dollars on this.
That's awesome. But we know what their morals cost.
Google shuts down malicious Google Play Story app. What did the app do? That's what I thought when I first saw it, too. I looked in 2 different articles to make sure it was spelled right. You guys don't know this one? Anybody know? It's an app that mimics Google Play, but when you use it, it takes your banking credentials and sends it back to the third party. Yeah. So it's one of those things that it looks exactly like Google Play. You can't delete it. It will tell you that you're deleting it, but it leaves it on the machine. All right. A Chinese company making smartphones ships the phones with what specialized software pre-installed? I heard somebody up here say that. Who said?
Certified pre-owned.
And not in the car sense.
Yeah, spyware. Who said that? Who said it? Where the points go up here? Oh, nice. Josh got 3.
You have a friend.
All right. What's the what?
That's 2014 in it.
Do you guys know this? During the broadcast, this guy's bragging about his control system, and so we say, let's zoom in here. You know what? All they did was copy what happened at the Olympics. They did the same thing.
They did lead speak, but instead of using a 4, they use an A. So almost lead speak.
Yeah, that's amazing. That's amazing. So let's tally the score up. Who do you think won? Who do you think won?
Wow, you guys are optimists.
Okay, as he's tallying that up.
I think they won.
I just don't want to lose to Chris.
Hey, I'll take that.
It would be.
How close are we to tally here? Did you enjoy that? Because I would really, I'll do this online once a month if you guys would log in and actually do it.
Well, the results are pretty unexpected. I really don't, to be honest, it's a total rout. So, number one in points, actually, okay, as far as raw points, Chris Ng has 22 points.
Ooh.
No negative points. So, final score 22. Matt, mainly because of generosity.
Got 157.
Crowdsourcing. Hello. Wound up with 24 points. Oh. 3 negative points. With a result score of 21. Oh. Josh, due to some last-minute speed ahead, not to mention jokes, which also helped give you points, 32.
Oh.
With a negative of 3, resulting in 29 points.
Nice. All right. So, thank you guys. I hope you enjoyed that. I try to do this at every AppSec. We rolled it out at AppSec USA in New York, and it was a hit.
So the first round is on Josh?
What's that? Somebody asked me where it would appear if I put it up. I am building a community for Nexus. For those of you that use Nexus, I'm building a Nexus community, and I'll be putting it up there, and anybody can just log in. You don't even have to log in. You can play it there. How's that? All right. So thank you. Enjoy the evening tonight. How many people come to dinner? How many people? That should be nice. I feel like I'm eating at Hogwarts without the owls. All right. So thank you, guys. Absolutely. There you go.